Right. Hello, everybody, and welcome to the Earth Observation Forum. I just wanted to say hi. I wanted to say that we're glad and happy and even proud to be organizing this. This is the Polish space agency called POLSA. And I'm Matt Gauts. My real name is Maciej, but I don't want to make anybody's tongue twisted because of these crazy letters. Polish names tend to be difficult, but not all of them. Actually, I know someone whose name is much easier to pronounce, and that's Marcin. Marcin Mazur, he's the vice president of POLSA. Marcin, great to have you. Please give him a big round of applause. Good to have you.
Thank you.
Yeah, it does. I think it does, yeah.
It does? Yeah. Thank you so much.
We're back.
Yeah, I'm back. It's easy to say Marcin even in English, so it's easy to be pronounced as well. I'm more than happy to open the second day of the Earth Observation Forum, especially for those who are with us in person and who are virtually. I wanted to say that yesterday, just to remind, or for those who are not able to be with us yesterday, that we had great discussions, great panelists and experts within urban area, agriculture and forest seminar sessions. About how to speed up, how to optimize the exploitation process, how to provide the products, the services to customers. And today we will have a chance to, as a co-organizer with Eurisy Association, to talk about global current challenges. It means climate change and lack of energy issues, especially nowadays during the current Russian-Ukrainian conflict. And I would like to say that I would like to encourage all people who are, as I said, with us personally and for those who are virtually, to participate actively with the discussions, to ask questions, and what I can say, I can wish you great day full of ideas and all the best. Thank you.
Thank you. I did want to mention one fact, and it's that you were a military person. We talked about it yesterday, but it also is a reason why you would be very fluent in English, because I think you spent a few years in the Netherlands.
Well, I try to do my best. I'm not fluent anymore. I think I did much better when I serviced. You are absolutely right. You went through my CV really well. But yeah, I try to do my best. Yeah, thank you so much.
So what was it in the Netherlands that was your responsibility back in the day?
I was actually geospatial officer, so the topic which is really connected to Earth observation, so all the geospatial data. At that time, the HQ, the headquarters where I serviced, was responsible for ISAF mission in Afghanistan.
Okay, great to have you, Marcin. Thank you for the opening, and I'm glad that we have a co-organizer, so maybe both of us can put our hands together for Annalisa Donati. You're the Secretary General. Great to have you.
Thank you very much. Good morning, everybody, and thank you, everybody. I mean, I see like a lot of people here, so thank you for being here, and also thank to the people at home that are watching us. And
maybe people in Italy, maybe people in France.
Hopefully, yes, for sure. We have a couple of speakers from France, and I'm pretty sure that they are followed by their students and the scholars and people in France.
Did you share the news? Did you tell them that they can watch?
Of course. Of course we did. This was part of our co-organizing duties.
Oh, it was actually one of the duties. A month ago, you were with the Slovak Space Office. So I just wonder about you and your roles. Is that you travel around Europe and you visit many agencies like ours?
We do pretty much. I mean, maybe let me just give 2 words of explanation on what Eurisy is and what we do. So indeed, Eurisy is an association of space agencies. Of course, Polsa is one of those. We have 20 space agencies at the moment, and the Slovak Space Office is also another one. But we have also, I don't know, the Italian Space Agency, ESA, the European Space Agency, and again, many, many more. And we do work mostly on 3 main pillars, which are the awareness-raising campaigns that we do on the benefit of a satellite-based application, and this is part of what we're doing today here. We do work a lot on the matchmaking, so making sure that basically the services and the solutions that adding values companies in the space sector are providing, they match with the needs of the final users, and they get basically uptaken and used by those one at the end of the space value chain. And also we do work a lot with policymakers to make sure that all the regulation barriers or like any other, let's say, obstacle that is in the path of the uptake has been removed and smoothened in this process.
What's an obstacle that you can remove or help remove?
Sometimes is about legislation. So sometimes, for instance, as we were mentioning, in the case of some industry, it's really like about not mentioning the use of satellite data among the different sources of data that can be used when it comes to monitoring of certain kind of things.
So sometimes the people who drafted the law, they didn't know, they didn't imagine that could be done?
Exactly. Sometimes it's just something that was done a long time ago when satellite data were more science fiction rather than, like an actual piece of information that it's really necessary nowadays.
Yeah, so who would have known back then, right? I mentioned that a month ago you were with the Slovak Space Office, but you were also kicking off the 73rd International Astronautical Congress in Paris.
We've been, yes.
Is this also something that Eurisy does?
We are also members of the International Astronautical Federation. For us, the International Astronautical Congress is not to miss yearly event. So of course, we generally use this platform to get to meet our members and to get to enlarge also our members base. And so of course we are there, and for us it's really like a milestone throughout the year to meet our community.
Yeah, and life in Paris also feels good, because I know you are an Italian living in Paris.
I do, but indeed Eurisy is based in Paris because we are hosted within the ESA premises. So we are within the European Space Agency's premises, so our HQ is within the European Space Agency headquarters.
Oh, makes perfect sense. And what also makes sense is that somebody that we will hear from a little bit later, that's Francesca, she also used to work at the European Space Agency. No? I just made that up? Yeah, I've looked into your future. Yeah. It was just me doing the crystal ball thing.
Maybe it was just a mixing up. I've been working at the European Space Agency for a while, yes.
Thank you for saving this. I've asked you a lot of questions. I wonder if there's just something that you would like to say to the audience.
Well, the only thing maybe that I would like to say is that today we do this kind of exercise, this forum. We want to have like you guys here meeting the people and the experts, because we want to make sure that in this time of extreme challenges to our society, which is climate change, extreme weather events, we know what we can do through the infrastructure that we build all together as European citizens. So this is like something that belongs to us, and now on top of the technological development that was put for the building up of this infrastructure, now we can use the services, and what we want to make sure is that it's very well understood from those that can benefit, again, at the end of the space value chain, so that users can really like uptake it and use it in their daily workflow. So we have amazing experts today that will explain a little bit what this is meant to be used for, and yes, I mean, I hope that everybody enjoys.
Yeah, I'm sure people will. Eurisy, great to have you, and thank you for co-organizing this. I know that you know Francesca quite a bit. Can you tell us who she is so that we can introduce her?
Perfect. So actually, indeed, so Francesca is my partner in crime in the organization of those workshops for the uptake. We've been working together in the framework of the eShape project, which is also something I want to mention. So eShape is a European Commission flagship project, and is about the development of Earth observation services capabilities. We have 37 pilot projects. Some of them are here with us today, ready to present what we are doing, and this is actually the European contribution to the GEO, which is the Group on Earth Observation System of Systems. So this is actually how we are contributing at the international level at this Earth observation, let's say, overall capabilities. And again, like we've been organizing this kind of exercise to make sure that the actual communities can meet with the Space One in order to exchange and to have like this trade-off, this feedback. So like actual users can tell to the service provider their requirements, and service provider can respond to the user's needs.
I like that, and I think face-to-face meetings are so important and so priceless. Because if you really want to connect to the community, that's what you really should do. Online is good, but it's just not enough. On which note, I wanted to ask you, how long does a train take from Paris to Brussels? Do you know that? Because I know you live in Paris and Francesca lives in Brussels. It's a long distance.
Yeah, it's doable. Now we have like it's like indeed 1 hour and a half. There is this amazing fast train that connects us.
Yeah, so let's take this amazing fast train and go from Paris to Brussels. So give it up both to Annalisa and Francesca Piatto.
Thank you.
So, Matt, my horoscopes have never been so punctual and precise. So, if I will ever work at ESA, it's thanks to you, by the way. So.
Yeah, this is the moment when it all started. Like when people ask you about your work there, you can say it started here in Warsaw.
I will say so. Thank you.
Thank you, Francesca.
So, thank you very much. Indeed, my name is Francesca Piatto, and I'm a project officer at ERSC, the European Association of Remote Sensing Companies. And today I will give short presentations about the latest trends and markets development for Earth observation services. So let me take my notes, and thanks, of course, to the Polish Space Agency for supporting us and coordinating all of this. Next, perfect. So what is ERSC? ERSC is the European Association of Remote Sensing Companies, which promote the activities of EU companies engaging in the delivery of Earth observation services. ERSC represents this this sector really in the broadest services, so making a connections and bridging between service providers, institutions, policymakers, and of course the users, covering the full value chain of this sector, from data acquisition to data processing and the final service. So it's good, of course, to be here and being able as well to see some of our members, because of course we represent European members, European companies in the downstream sectors, around 130 members plus from 25 countries in Europe. ERSC every year presents, let's say, the result of the state of the health of the Earth observation sector. So since different years, every year we've been providing these results, and previous surveys stream from 2013 with the most recent one in 2021, which actually will be published at the end of the month. So my presentation will be providing some results, but especially focusing on the survey of 2020, which is the most recent one in cooperation with ESA. So just to make sure that all the data that we're going to present, of course, make reference to the previous year. And to have a quick glance, we can see here that our survey was completed with a direct research with over 713 companies, with a specific sample of 115 companies. And we can see that the market employees market is been increased of 17%. We have a 1.71 billion revenues, and then at a steady growth rate of 10%. The survey report is going to be very, very, very big. It's a 50-page report, so for a matter of concision, precision, and time, of course, it's going to be. I'm going to focus only on some key figures, and this will be the number of companies, employment, revenues, but also the barriers and the obstacles to the EU market uptake. And during this presentation, I will also put some inputs around the Polish space sector as well, because the Polish space sector is very young, but is so active, and there are so many stakeholders active in this sector that can really bring so much added value. I think it's very important as well to give a little bit of strategic and policy context. So the key trends figure in 2021 were really the new allocation budget of 14.8 billion with a proposition of Copernicus of 5.8, but also the establishment of the new agency of EU SPA in the new space program. What does the European industry look like? So we can really see from this figure how the composition and the distribution of EU companies in Europe are formed and distributed. And here we are taking really in specificities the European countries making part of the EU or ESA, hence the 32. But we can also share how companies are distributed within the European ecosystem. In fact, we can see the final, let's say, numbers of 2020, which are definitely break down between 2018 and 2019. And this is really, we can really see how EU companies are basically UK, Germany, and France. But that doesn't mean that in terms of employees, like in the employee sector, UK has yet fewer employees rather than France and Germany. We can see Poland in a few steps later, after, well, Spain, Italy, and Netherlands. This is, I think, it's a good point in any case to showcase, because as I was saying, Poland the Polish space sector is extremely active. It's young, but it's really moving forward. There are many stakeholders, more than 700 entities, of which mostly are also SMEs, research and development, and scientific. So it makes sense that this trend, of course, will be increasing. In terms of employment, we can say that the total number of employees in the sector in 2020 has been 11,600 in 2020, a number that corresponds to the trends of 2019. This means that we have been having a growth of almost 40% in the latest 2 years. But the biggest growth in terms of employment in the EU sector has been found in the small and medium categories. That means because new kind of sector and stakeholders have been entering this new Earth observation sector, and it's mainly IT component. IT players are really offering now infrastructures as a service, and almost around 300 people are already working in this sector. But also, there are companies offering GI services, so geographic information services, that are starting to use EU data in their own sectors, in their business. And so we can say that these companies were already, let's say, existing and were grown even before entering this services sector. In terms of revenues, we have a consistent and sustained growth of around 10% per annum. Total revenues amounting in 2020 to 1.70 billion. And we can say that, again, the small companies are those that are generating the most of return. In terms of employment, and I would like to reconnect, of course, with one of the questions from Matt about what are the main barriers in the uptake of the market. And I would like to take a step before in terms of skills in the employment sector. Nowadays, from our survey, we have really understood that skills, it's really a topic that of extreme importance for companies in the Earth observation sector. Close to 3-4 companies reported difficulties in hiring staff, for example, due to lack of transversal and business-oriented skills, data management, competitive marketplace, but also lack of trained staff in the EU sector, in specific EU countries. Companies in our survey were also asked to showcase which are the most difficult skills to acquire. And the answer were about programming, development capabilities, but also analytical methods. So this really means that skills are super important within companies, and the importance of upskilling, but also reskilling, the already established stuff. So especially artificial intelligence, machine learning, data management, and analytical methods are really required, especially in view of the growing volume of EO and other type of EO-space data in the sector. I would like now just to retrieve a little bit your view on the types of markets and, let's say, the kind of communities that are already using Earth observation, but also who are these end users that are really make use of this type of data. I have to say that compared to our results in 2019, there has been really a growing amount of companies making use of EO data. And we can say that especially at market geography uptake, it's really important, especially for ERSC, because of course it's within the framework of internationalization. And we can see that at a market point of view, Middle East region is really getting very much traction in terms of acquiring data. In terms of communities, let's say, and services, defense and security, which before, let's say, was also integrating the emergent services, which was into another sector, is one of the main market, followed by agriculture, environmental ecosystem and pollution, oil and gas, up to forestry, and then, of course, citizen society. I wish and I hope I'm correct to achieve a little bit of comparison also with the Polish market, in the sense that among the different domains identified by potential EU companies using data, agriculture and forestry are also one of the main domains in terms for mapping land agriculture, but also fire detections, disaster management, and so on. And of course, public sector is one of the main, let's say, end users, and also one of the most important as well here in Poland. But again, this kind of end users sectors are difficult to explore, are difficult to, let's say, make them aware of all of this. And this is why of these barriers perceived. So we were talking about what are the main barriers to the perception of the integration of EU data. And one of the most important, and the first one in our diagram, is really the market acceptance. So we really have to open not only the market, but also the end user. So that's why projects, for example, like eShape, are really important, because they really bring us in connections with new type of community in order really to expand the awareness. Most of the time, it's really a lack of awareness of the utility of EO in a business process. Usually, Earth observation is really seen only as a part, only as a component, and customers are really not ready, let's say, to develop, to invest into a very final product. Solutions are still seen very complex, lack of policy, let's say, tractions to endorse the usage of technology in this product. And as well also the cyclicality of the industry, in the sense that undermines sometimes also the long-term commitment from users. We were talking about awareness. What's the easiest and the most important things to do? It's really to share, showcase success stories and studies. I would like to start already from Eurisy, which is doing an amazing job in showcasing success stories. In terms of ERSC, we have been developing the Sentinel benefit studies, which really wants to showcase the benefits and measuring the impact of Earth observation services along the full value chain, from the economic to science technology benefits. I have here an example of farm management in Poland, so if you're interested, feel free to visit our website. I'm told that I'm running late, so I will conclude in here. how the European Union, how the Commission, through projects, Earth observation is fostered. We're here for eShape, but we're also here for other projects, for example, which are really making use of this thematic through a co-design approach, really in order to get to the final user communities, which are not EU knowledge, for example, but they could very much integrate all of this. I know that, for example, Poland as well, with the Polish Space Agency, has been involved in many national and also international projects. So this is also one of my future forward looking to take part in these projects. And I will finalize my presentation here. And then should you have any questions, I'm at your availability. Thank you very much.
Thank you. I do wonder if somebody has questions. You can also ask them in Polish and we'll just translate them.
Or so later in any coffee,
right.
if you're late, there's no problem.
Right. So I don't see any questions quite yet. I've checked in the app as well, and we haven't, but you know, it's just the beginning of the day.
We have a full day ahead, so
yeah.
Can be later with no problem.
So you live in the Netherlands?
No, I never lived in the Netherlands. I would love to, but
really?
Thank you so much for this geographic expansion.
But Belgium, right?
Yes.
Brussels.
Yeah, Brussels. Yeah.
Brussels.
Yeah.
And previously you were in Ireland?
Yeah, previously I was in Argentina, and previously I was in Ireland.
Okay.
Yes, I've been for studies and work with the Italian Chamber of Commerce. I was traveling around, let's say.
Is it common from people from the space to travel so much?
I think I would push it forward in terms of projects as well. This is one of our capabilities in order to travel, in order to meet, to organize this kind of workshops where we can really meet with physically with people who can really benefit from all of this. So it's true that during the pandemic we stopped. Basically, it was already the beginning. So we are starting now to retake these trips, these work trips, but it's always nice because we can meet your partners, your colleagues as well. So it's a good environment, absolutely.
Yeah, and I know that at some point in time you studied interpretation in Padova.
Yes.
Was there a time of your life when you wanted to go into interpreting?
Yes, but mostly interpreting, indeed, yes. I don't know why, especially in diplomacy. So I work a little bit with some organizations to do interpreting. And then I wanted really to, let's say, break through into the international organization. So that's why I also wanted to move to Brussels, but mostly from my point of view of EU external relations. And then I would say that the passion starts from there. So researching climate change, environmental migrations, and it sort of brings me to the usage of satellite in order to tackle these IDPs.
So it's interesting because your passion for languages also somehow brought you to these topics.
I would say so. Yeah.
And Brussels obviously is a place where a lot of interpreters are needed.
Yes.
So you probably know that it's a hard job, and that's. I just wanted to take this opportunity to say hi to Paweł Kozłowski and Sonia Darzycka. So they are professional interpreters.
Fantastic. I can really feel like sometimes the difficulty in all of this. So I totally understand about sharing as much as information as possible before our presentations or any abstract, because the procedure in order to get ready to it, from your glossary, from your context, from understanding the topic, it requires a lot of time. So I share with you this work, absolutely.
Thank you for saying that, Francesca.
Absolutely.
It was wonderful to have you here.
Thank you so much.
And I'm glad because Annalisa will be coming back to us. She will be our co-host for this part of the conference. And this one will be about solar energy.
Yes, exactly. So we've been talking today that the day it's devoted and all the, let's say, sessions will revolve around climate change and the topic related. So solar energy and renewable energy in general terms is one of those, very important. So this is indeed our first session. We have like three speakers that will present their work in terms of renewables and especially solar energy. And I think that indeed
Some of them are already
exactly
here.
no further delay. We can move forward with the presentation and leave the floor to the actual expert.
Yeah.
I let you pronounce the name of Piotr because I believe that you do it better than I can.
So that's where I can help. So it's Piotr Struzik and Bogdan. You try that.
So
Bogdan.
Bochnek.
Yeah.
Sorry.
That's Bohenek.
Bohenek.
Yeah.
But repeating, I'm good. So.
Right. Italian is such a great language because Italian reads the way it writes.
Exactly.
Right. So
we're easy people. We like to make life easy. So I mean, we read how it is written.
You guys are molto bene people.
Exactly. We try at least.
And you have the wonderful gestures, and we just love Italians. I am curious if Piotr and Bogdan are here. I know that they are joining online.
Okay.
Great to have you, gentlemen.
So both of them from, I guess, the Institute of Meteorology and Water Management of the Polish National Research Institute, talking about solar energy. So welcome and thank you very much for being with us. The floor is yours.
Yeah, and please be so kind and try to take about 10 minutes. Thank you.
Good morning. Do you hear me?
Yes, we do hear you.
Yay.
Ladies and gentlemen, thank you very much. I will be alone today because Bogdan Bohenek cannot attend. Okay, so I will follow. The title of my presentation is Monitoring and Forecasting of Solar Energy with Use of Satellite Products and Models. And what I will be talking about. Just a moment, but my slides are not changing. I don't know why.
We see your slides, so it's okay.
But I see only the first slide, sorry for that. Maybe that will be, now is okay, thank you very much. I will go into the presentation. Okay, so let me first short introduction, then for products which is used in this study. This is a UETSAT Landsat downwelling surface shortwave flags, and then use of this product at our institute, and finally about the model using artificial intelligence for solar energy forecasting, the first test of this model, and some conclusion at the end. Talking about the solar radiation, it's necessary to say that at Poland we have the ground station which measures the solar radiation at the ground, and using the very simple equipment comparing to the satellite technology, which is more see the issue of the 67. It was the first system to receive the satellite data, an example of the satellite product which could cover the whole hemisphere visible from the surface, from the satellite altitude. The EUMETSAT Landsat DSSF product, it is a product which measures the amount of downwelling shortwave solar radiation, and it is prepared to deal also with the cloudy conditions and with the clear conditions. So depending if we have cloudy or clear conditions, at the first we use the 3 channels of the BTOSat second generation satellite, the channel 0.6, 8 and 1.6 micrometers. Then those channels are converted to data. The channels are converted to broadband albedo, top of the atmosphere. Then there is calculated atmospheric transmittance for cloudy or clear conditions. And finally, the solar radiation flux at the Earth surface is calculated from those data. What we are getting represented by on the left hand, you could see the measured solar radiation measured at the ground, and on the right side you could see the measured by the satellite, observed by the satellite. You could see that the fluctuation of the ground measurements are much higher than the satellite data. It is due to the size of the pixel at the ground measurements are point observation and the scattering of the solar radiation over the edges of the clouds, especially when we have the cumulus clouds, shows the very, very variable data at the ground. The satellite pixel is much higher. It is 5 kilometers, 5 by 5 kilometers about. So the data are smoothed, and we could see the time curve of the satellite radiation much more smooth comparing to the ground measurements every 1 minute. If we look on the sun. On the cloud-free days, we have the same from the satellite. And remember the cloudy conditions, of course, the 1 minute measurements of the ground cannot be repeated by the satellite, so we have a little bit smooth curve.
Przepraszam?
We will compare the values
Przepraszam, czy pan mnie
of
słyszy?
the solar radiation at the ground measurements and from the solar.
I'm sorry, can you hear us?
Especially in the summer months, there are
Przepraszam
some
pana
differences,
najmocniej.
which are the summer months. There are some
Przepraszam?
slight small differences due to this clouds, especially cumulus clouds, which make the scattering of the solar radiation. During the remaining part of the year, the values are very similar. And if you look on the distribution of the solar radiation over the larger area, like area of Poland, we could see that using only 25, or in this case only 19 stations, because not all of them were available. It's not a very detailed image of the solar radiation. If you look on the right side, you could see that from the
Przepraszam,
satellite,
czy pan mnie słyszy?
the area of Poland about 24,000.
Excuse me, sir, can you hear us?
Detailed structure of the solar radiation. And here is the value. It is a 15 years period, 2004 to 2018. And on the right, you could see the distribution of the solar radiation. It is the annual amount. In Poland, you could see the lowest value in the mountains and in the Pomeranian region, the northwest part of Poland. The highest value in the southeast part of Poland, in Lubelskie and Podkarpackie provinces. And also, we could see the some details like the Vistula River valley, part of image where the solar radiation is much lower because very frequently there are low clouds or fog. On the right down, you could see the amount of solar radiation in each year starting from the 2004 to 2021. We could see that the most sunny years were 2005, 2011, 2015, 2018 was a most sunny year in this period. And we have also rather cloudy years like 2008-9 or 2017, which has much less values of the solar radiation, even less than half of solar radiation in the peak of sun 2018, for example. If we compare the different years, we could see kind of climatology of the solar radiation, but we could see that not all years are the same. We have some years which are very sunny, like 2005-6, 2011, 2015, 2018, and we have very poor years like 2004, 2008-9, 2017, especially in the northern part of Poland. We could see that not each year we have the same amount of solar energy over Poland, and even in the individual parts of the Poland, there are big differences of the solar radiation. If we look at those annual mean from the 15 years, 2004 to 2018, we could see the important changes in each month. Here we have the cold part of the year, December, January, and February, and we could see that the highest solar radiation in the south part of Poland, especially Małopolska province, is very sunny, and close to the mountains are really much of sun. And in the north there are much less sunshine. Of course, it is due to the position of the sun. The sun and earth is very important at this part of the year. Looking on the springtime, March, April, May, we could see that the amount of solar radiation is rising, is going up. And in May, we could see a very important feature that close to the seashore, we have much more solar radiation than a bit apart from the seashore. We could see the band of the higher solar radiation close to the seashore, and quite much solar radiation in the central part of Poland, Wielkopolska region, Kujawsko-Pomorskie, and these areas. In the mountains, they are starting more clouds, more storms, and in the mountains we could see much lower solar radiation. Looking on the summertime, June, July, August, we again see June, July, very privileged Baltic Sea surface. The Baltic Sea and close to the Baltic Sea shore that have very much of sunshine. In July, we have especially peak of the sunshine in the southeast part of Poland and east part of Poland. In August, we see that solar radiation is going down, especially in the Pomeranian region. There are much lower values, but still the southeast part of Poland is at the peak. And again, in the autumn time, September, October, November, we are slowly returning to this latitudinal shape of the solar radiation. Especially in November, we could see that the latitude is very important for solar radiation. Looking on this year, we have the balance from the January to October, and we see that the amount of solar radiation. Of course, the scale is different for each picture. Maybe you do not see the number, but in January it's about 40 kilowatt hours per square meter maximum. In February it's about 60. In March is 125. In April we could see that the especially south part of Poland was very cloudy and very poor conditions, while the north part of Poland was much better. Anyway, we are peaking to 180 kilowatt hours per square meter. In June, we have the very privileged east part of Poland, and north is a bit worse. And going to July, we have about 180, August 150, September 120 in the peak, and October we could see the south part better than north part. Most important are anomalies, because we have our climatology, we have the values from the 15 years, and we have actual values. We see that anomaly in this year was very important in March. March was very sunny month. We have a very big values, about 30% more than the multi-annual mean. April was very poor, especially in the south and southeast part of Poland. Again, June was quite sunny, especially at the south. And September was very poor, especially in southeast, and October was very sunny again. Of course, we have not only the maps of the solar radiation, but we have also diagram. For example, here are diagram for the Małopolska province in the decades, and anomalies in the decades of this year. We see that the very sunny March, very poor April, again poor September, very nice October. So we could see the diagram of the solar radiation in all decades. Talking about solar radiation, very important is not only monitoring of solar radiation, but also forecasting of that. IMGW is the active member of several numerical weather prediction consortia. It is Accord, Cosmo, and RCLACE. They could produce the short-range forecast up to 3 days, and also we have access to the global models up to 14 days, and long-range forecast up to few months. And we prepare using the artificial intelligence. We could use the different models shown here, but the most important for us was the first 3 days. So we were using the mesoscale models, and you could see the references in terms of accuracy of forecast for different numerical weather prediction models are important. For example, here example for the WRF model and for AROM model, we could see that the relative mean bias is lower for the WRF, a bit higher for AROM forecast for AROM model, those closer to 20%. But if we look on the correlation coefficient, AROM model is better. It is about 0.9 correlation coefficient, while WRF is a little bit poor. And also the root mean square error is about 15 to 20% for our own model, so it's not bad. Of course, talking about the forecasting, is necessary to say that the continuous values like temperature, humidity, pressure are very well forecasted, while such discrete values like cloudiness or rainfall are not so good forecasted. Of course, we are doing also the analysis of existing databases related to solar energies, comparing them with the actinometric measurement, and also with our prediction of the solar radiation. We are checking the databases of CAMS, SODA, IRA, and looking for the values. Very interesting case was on the 25th of October. It was the solar eclipse, and we could see that the solar eclipse influenced production in Poland. Here you can see the previous day of the solar eclipse and the next day, and we see that in a drop of the, and here we could see the actinometric measurements and also the very big drop of the solar energy. In conclusion, we have seen that the satellite products the opportunity to monitor available solar energy. The spatial resolution is adequate to local requirements, and repetition time is starting from the 15-30 minutes and also 24 hours for the daily values. Operational products made possible monitoring in near real time. That's very important because we could observe the the efficiency of our ground systems for the solar energy production. A long series of observation allow to create climatological time series useful for monitoring of anomalies. We produce the maps of daily, decadal, monthly, and annual amounts, maps of decadal, monthly, and annual anomalies, and also diagram of decadal amounts and anomalies for 16 provinces and 360 districts. Our model the created model trained by satellite products is useful for prediction of solar energy production for the next 3 to 5 days. Thank you very much.
Thank you. Thank you very much. It was great to hear from you. Actually, can you hear us?
Yes, I hear.
Oh. That's a nice surprise. We didn't know that. And to be honest, we weren't able to see your presentation. We weren't able to see your slides.
So you don't hear me at all?
We heard you. We just didn't see the PowerPoint presentation.
Oh, it's a pity.
I know.
I have to went down with the volume of the voice because I hear at the same time when I was talking, I hear the translation and it was disturbing me. So
I have this idea that maybe
so
you could.
I'm very sorry.
Right. Maybe you could send your slides to the organizers, and then we will distribute them over. We'll just send them to the people that would like that. Annalisa.
Yeah, exactly. So we will make sure that the participants will have the slides later.
Right. Do you have any questions? I did expect that because, to be honest, Professor, it was just hard to hear you at many times.
It was a little bit difficult. So
Yeah.
I don't know if the people that are following online, they have any question, please don't hesitate to put it in the chat and we will make sure that we will pose the question to Professor Piotr.
Sorry, I'm not professor, I'm only doctor.
Thank you. But you were very brave, and so we wanted to thank you for that. We have this special round of applause for you. And we have our new presenter also joining online, but I've heard from the guys running the boards that the connection is very stable, that we should be able to both see the presenter and the slides.
Great.
And I think you know them.
We will move to the next presentation, so of Mr. Amare Silva. So it's from Armin Paritech, the technology university in Paris, France. Mm-hmm. This is one of the E-shape pilots on photovoltaic penetration at urban scale. So indeed, Rodrigo is a postdoc researcher in the photovoltaic field. He participated in several projects and is researching in this field. And again, we will move to the next presenter. Can we see if Rodrigo is online?
Yes, I think he's here.
Great.
Hello, sir.
So, hello.
Hello, everyone. Connection okay?
Great to have you.
Thank you for inviting me as well.
Great. So can we ask to speak slowly because the people otherwise won't understand, right. And also we have interpreters here that are translating everything in live time. So please mind the interpreters and
I will try.
Well, thank you very much again for being with us and. We leave the floor to you.
Yeah, we have about 15 minutes for you. Thank you very much.
Okay, thank you. So I'll wait for a confirmation that you can see the presentation, okay?
Yeah, yes. We do. We see the presentation.
Yes, it's here.
Okay. Okay. So hello, everyone. My name is Rodrigo. I'm from Armin in France, as it was said. And I'm here to tell you about a bit on a pilot from E-shape, a European project which was briefly introduced before, and I'll get back to it later on. And the focus will be on how in this pilot, we try to explore Earth observation data to improve and create products for the urban environment, so for cities. And so I will talk about cities and solar photovoltaic, the E-shape project, and some examples on what we are doing. And so when we talk about cities and photovoltaics, we have a very good match of a location where we have lots of people, lots of service, and so we have lots of electricity needs. With the same time, that same location having lots of available surface. We can talk about the floor, the roads, the rooftops, the facades of buildings. And then we have a technology which is super modular. We can go from a very small PV module to a lot of PV modules covering a large area, and which is quite adaptable. And so we can put it flat on a rooftop. We can put it curve to make this kind of shadowings, as you see here on one of the images. And so we have a good match between lots of electricity needs with the potential to generate clean solar electricity. However, there is one thing in cities which is quite almost impossible to avoid, which is shadowing. So the shadows that the big buildings create over lower elevation locations. And we can see on the right image how we can have this great modular and clean technology. But if we have a tree or a building which is creating a shadow over this, we will have less solar radiation, and because of that, we will have less solar electricity. And so this is a challenge that needs to be addressed. We need to first try to avoid it, and in cases where we cannot, we should be able to understand the impacts and predict beforehand what is going to happen. And to do this kind of stuff, a variety of Earth observation data is needed, starting with the digital surface model, which is just a 3D map of our cities so that we know where are the buildings and what is their shape. And at the same time, solar and weather information so that we can also understand the kind of weather that we're going to do. Is it a sunny day? Is it a cloudy day? And so both of these components are very important. And based on this, we can create some products just like this image on the left, which is called a solar cadaster, which is a map where based on color, and in this case it's like darker color and yellow color, we can distinguish where it's best and where it's worse to put PV panels, PV modules. So that if it's a darker color, we know there's lots of shadowing, and so we should avoid it or try to avoid it. And if we have a yellower color, we should really try to make use of that surface to explore this clean energy. And so this thing I'm showing you now is not novel. It's actually quite a traditional kind of product, based on which we can also do some economical evaluation to tell people, look, if you put a PV module here, it will cost this money, it will make this money, and so you will have a result of profit. And this information is of interest from people such as ourselves, citizens, to policymakers who have to decide where they should promote more this kind of technology. But even for the companies which need to install PV panels, they need to know the potential of what they're working with, so that they can give better estimates to their clients, for example. And this was actually a product that our group developed already a few years ago, maybe 8 years ago. And when we did this work, we noticed back then that it involved very heavy and slow computations. And it also required lots of data, which puts lots of limitations and compromises, such as we have to work with small areas. We can only show people the annual potential of their rooftop, for example, but we cannot differentiate how good it is in the winter and how good it is in the summer. And in case we needed to repeat calculations or we wanted to improve calculations, it would need lots of time. And so that's not good enough. And that's where our participation in eShape comes in. And so eShape is a 15 million euro European project with lots of partners addressing several topics such as agriculture, health, or for example, renewable energy, where we are positioned. The project ends next year, and the goal is to promote the use of these kind of tools by the target stakeholders that we identify. So we should make it more useful, more accessible, and easier to use for the people that we want to address. And this is mostly done through the co-design of demonstrators. And this co-component is important because it means we are involving our partners so that we can have different perspectives with a more complete product. And our pilot number 2 inside the renewable energy showcase, it aims to develop tools that support high PV penetration, so lots of PV at the urban scale inside cities. And we have different expected users that we have identified, and this is done by also a collection of partners, such as you can see in this slide. So to do this, we started by setting up a specialized IT infrastructure, first creating super optimized algorithms, which then are implemented using these 3 elements. So the data and information access services, WIKIO by Copernicus, some web processing services, so that everything that we do is done through the web and on the cloud. And in the end, we also use Jupyter Hub, which I'll show a bit later on, as a front end to show the visual component of what we do. And so actually, based on the limitations that I identified before, our first goal was making stuff fast enough so that you can move from this static image, which has a color scale, but it really doesn't change. It has a single layer of information, to a more dynamic setup where we can actually, so in the right we have the same city, and we can not only see the shadows, but we can even see how they change throughout the day. And so we see the impact of the sunrise in the morning, the shadows moving throughout the day, and then the sunset in the end. And so having this kind of information, it allowed us to make some interesting use cases. And so I will show you 2 examples, but we found many more. So the first one is it's PV sizing for self-consumption, which is quite similar to the traditional tool which I showed you, where you have a map, you have data, and you have estimates. But instead of that static image and that single layer of information with one cost, one revenue, and then the profit, we develop an interactive tool based on Jupyter Note, which is the image we are seeing now. And so the user just navigates through this page. You can see then a map. And in this case, we set it up for France because our partner was French. And so you go into this map, you can zoom in. You can choose, for example, your house. It could be like the polygon on red. And based on that, it will give you, with yellower being sunnier and bluer being less sunny, we can identify where in your rooftop you should put your PV panels. And so we can see from this image that half of it, the side that is seeing south, is naturally sunny, and the other side is not so sunny. And then, more than just giving you that single value, we are able to provide users values month by month. And for example, here we distinguish The red is what, if you have a PV panel, you could generate. The blue is what you still need for your needs, and so you import from the grid. And naturally, mostly in the summer, there will be periods, smaller periods, where you produce more than you consume, and so you have actually extra generation surplus that you can just sell to the grid. And we can go as low as, for you to know, 15-minute information. And so this gives people and companies a lot more information so that they can understand the potential of installing a PV system at their house. The second example that I wanted to talk about, and it relates with the previous presentation, it's on forecasting. So it means that I can anticipate how much generation I will have in the next 15 minutes, half an hour, 1 hour. And this is quite relevant because imagine that there is a service where you can sell to your neighbors your energy. To do this, you have to tell them how much energy and when will you have that energy to sell, so that you could receive almost a notification on your smartphone saying, Rodrigo wants to sell this energy in 1 hour. And so if you know that you need to use energy in 1 hour, you can buy it from me for cheap. And so for that, we need good forecasting models, which also take into account the shadows from the buildings. And so, for example, on this image here, the first square plot is just an image of the sky and the shadows moving through. Based on this, we identify where are the clouds moving to. And so we can see if there is any cloud that will arrive to our destination in the near future. And based on that, we can do this kind of forecast, as you can see here moving below, where we can anticipate with up to 1-2 hours ahead how much energy we will have. And so with this, I conclude. I have no idea if I respected the time or if I even was too short. But if I was short, it will be good for other people on the session.
Thank you very much.
Thank you very much, Rodrigo, indeed. And we can maybe take a couple of questions here from the audience.
By the way, did you hear the applause? I was curious.
Yes.
Okay,
yes,
I'm
Thank
glad.
you, everyone.
Does the audience have any questions? Anyone?
Any comments?
I have one question that I wanted to ask. So, do you think that many people can have solar panels installed in the wrong parts of their roofs? Like, can you imagine this being a situation for many people? Like in the less optimal areas?
Yeah, no, it's quite a good question. I would say that a good part of the companies should have the expertise, and I believe they will have, to try to anticipate and understand where it's best to place the rooftop. But it's also true that there are not that many tools accessible, which makes this kind of finding, the understanding where it's best or it's not so best. There are not that many tools to do so, because to have these maps of the cities are not easy to get. And that's exactly one of the motivations for our work, is to develop easy to use tools so that anyone can do it correctly and don't leave it to, are the technicians good enough or are they aware of shadowing impacts?
Yeah, I feel like this is something that is only starting, that in the future, people that want to have photovoltaic installations on their roofs will start to use software like yours, but this is probably just the beginning.
Yeah, no, and it's also important to I can share as well that in Portugal, for example, I think it was in the 80s or the 90s, maybe more the 80s, technicians were insufficiently prepared to do a good job, and that made that there was a whole period where lots of PV installations were not so good, and that made that citizens were suspicious because they were never sure if the guy who is going to install this PV system, does he or she know how to do it? And so to create these tools ensures that stuff is well done. And when things are well done, people become more confident about it. And so it creates like a positive feedback where we see more and more people getting PV panels, for example.
That's indeed great news, and indeed we hope that this trend is going to grow. So indeed, renewables will become something that it's for everybody. So thank you very much, Rodrigo. I don't know again, Matt. Do we have any question online?
I'm just checking. So here's the day 2. No, right now it doesn't seem as we have questions online, but I'll just take the last look at our audience. You can always raise your hands just in case.
And also, I mean, Rodrigo and Philippe and the team that it's working on this pilot project and shape kindly gave us their contact. So if you have any question and any further comment, you would like to engage with them to indeed bring forward this pilot, please let us know and we will be happy to put you in contact.
Yeah, and I wanted to thank our speaker from Porto, right? Or from Portugal?
So I'm actually from Lisbon. Okay. I'm Portugal, but I'm from Lisbon. But you're actually looking into the future because it's possible that in the future I'll go to Porto. So well done. Good forecast.
I understand it has happened before. Yeah. We have this crystal ball here in Warsaw. By the way, I just wanted to finish up your presentation by saying something that I found on your slides, and it's "In Sun We Trust," sir.
Indeed, that was a good one.
That's actually that's a French company, so it's not my own inspiration. So right. It's a French company who chose quite a good name for their work.
Thank you very much for joining us.
Thank you, Rodrigo. So I think we can move to the last speaker of this session on solar energy. So we have Elias here with us, Fontoulakis. I hope that, again, I pronounce it correctly. So
Great to have you, Elias.
Senior researcher from the National Observatory of Athens, especially from the Institute of Astronomy, Astrophysics, Space Application and Remote Sensing. And today we'll present the pilot project called Next Sense about solar energy nowcasting and short-term forecasting systems. So I let Elias take over and start with the presentation, and we take a couple of questions later.
Okay, so hello. I will talk to you about a system that we have developed for solar energy nowcasting and forecasting, which is called NextSense. So I will begin with a brief introduction. For the mitigation of climate change, many global and international initiatives have been triggered, and renewables will play a key role for the success of these initiatives. And solar energy, relative to other renewables, has two advantages. It's cheaper, and at least now it's cheaper, and it creates more jobs. Thus, it is expected to play a key role for both the United Nations Agenda for Sustainable Development, as well as for the success of the European Paris Agreement. Now, in Poland, it's not that shiny, so at the moment, only a very small fraction of the country's electricity needs are covered by production from photovoltaics. So in 2020, only 1.5% of country's electricity was produced from photovoltaics. Though this fraction is expected to increase. The corresponding fraction in 2021 is estimated to 3.5%, while until 2025 it is expected to reach 10%. The increased demand for energy and thus for renewable energy leads to the need for optimized production and adaptation to the electricity grid. So, fast, accurate, and high spatial and temporal resolution forecasts can contribute significantly towards the better integration to the grid. Now, in order to forecast and nowcast solar energy in different time scales, we need to know and understand changes in the atmosphere and how they affect solar radiation. We can thus utilize European Earth observation resources and provide new products and services towards the better management and development of solar energy related products. Our objective when we created NextSense was and still is to provide Earth observation and Copernicus-based nowcasting and forecasting of broadband and spectral surface solar irradiance and solar energy at the highest possible spatiotemporal resolution. The product currently covers Europe and part of the Middle East and North Africa around the Mediterranean basin. It can be used by different type of users, for example, grid operators, power and electricity corporations, ministries, etc. The supporting infrastructure is GeoGradle as well as the Beyond collaborative ground segment data site. And partners to this effort are those that you can see in the last line of this slide. So I will move on to some technical details. In the beginning, we developed a system for solar energy nowcasting. So we used a number of satellite and climatological products as inputs into a fast radiative transfer scheme, which involves radiative transfer modeling and neural networks. And the output of this scheme, of this system, is solar radiation and energy on a fine spatial resolution of 5 by 5 kilometers. And at the beginning, the products were available in real time. So we produce solar energy-related quantities such as the global horizontal irradiance, commonly called GHI, the direct normal irradiance, commonly called DNI, as well as the solar radiation that reaches to tilted surfaces. Using this scheme, we are able to calculate spectra for the whole solar spectrum, for the full range of the solar spectrum, for 1.5 million pixels at the grid that I told you before. And all this process takes less than 3 minutes. So we achieve having an estimate of solar energy all around Europe with a delay of only 3 minutes, since we have the satellite information, which comes in real time. In the context of eShape, we added one more module to our system, the Cloud Motion Vector module, which allowed us to have the short-term forecasting. So we used motion vector techniques, and actually we predict how clouds are going to move in the following 3 hours. And then this way, we provide the short-term forecasting with a step of 15 minutes for the following 3 hours. This process is also very fast. And the last product we try to develop now is long-term forecasting product with an horizon of 3 days ahead. For this purpose, instead of making the cloud motion forecasts ourselves, we use predictions from a numerical weather model. This product is in a pilot phase, so at the moment this product is available for 25 positions in Greece only. And now I'm going to show you some applications and users of the next Sense products as examples of how these products can be used. One of our users is the Ministry of Electricity and Renewable Energy of Egypt. They use our products for solar park characterization, planning, and economical studies. We have made a solar atlas for them, and they also use the nowcasting and short-term forecasting services. Mahdi Yacoub Heart Foundation Center in Egypt also use the system in order to electrify in the best possible way a hospital and the surrounding area. One more user is the independent power transmission operator in Greece. Actually, when we contacted them, we didn't produce this long-term forecasting product. This is something that they asked for, and in collaboration with them, we developed it. So they use the long-term forecasting, and they try to increase the share of energy from PV panels in the mixture in Greece. As you see now, As you see now, the share of renewables is below 15%, but it's expected to increase in the following years. The Public Power Corporation in Greece is one more organization that uses the short-term forecasting and the nowcasting. They use it to optimize integration of solar energy in the grid, and they were also interested about how aerosols that play a significant role in the region of the Mediterranean basin affect the production of solar energy. So we made a study about that, and here are some results. The system has been also used in India from the independent power transmission operator and some companies who want to find the optimal positions for installation of PV panels. And lately, we have a collaboration with the Eratosthenis Center of Excellence in Cyprus. They try to adopt the system to the needs of the Eastern Mediterranean and the Middle East. Since we produce spectra and not directly the solar energy quantities, we can use the system for more applications. For example, we can forecast and nowcast health-related quantities as the ultraviolet index, the effective quantity for DNA damage, or the effective quantity for the production of vitamin D in the human skin, as well as quantities related with agriculture, for example, the photosynthetically active radiation. And in these two slides, you see how we produce the UV index. The UV index actually is a quantity related, which expresses how which quantifies the ability of ultraviolet radiation to cause erythema in the human skin. So this service is being used by a cruise company to inform their clients who can then take appropriate protection measures. This map is a climatological map of the photosynthetically active radiation for Greece, also useful for agricultural applications. And this is another potential use. It's very similar to what the previous speaker talked about. So the system can be adjusted in order to get specialized predictions even to the scale of a building. Making a summary, an overall summary, we saw that by exploiting high-quality observation information, we can provide high-resolution solar radiation and energy nowcasting and forecasting. We have produced the next sense and UV-IOS systems for this purpose, and there is potential for further development and applications for scientific and operational use, especially, and these applications can be tailored to the needs of the users. So thank you for your attention, and here is a slide with the team that mainly works on these things. So thank you very much.
Thank you. Thank you very much.
Elias.
We have microphones for all of us.
For everybody.
Please come closer.
Give me a second.
Yeah, just get some water, of course. Do you have some questions, dear audience? So we've been seeing how the different days of the year, the different amount of sun that they can give. Is that something that will a day come when we will be able to have more clarity?
Well, can you hear me? Okay. I will give you an example. During the first lockdown, there was a coincidence of very clear atmosphere in Central Europe with nearly no cloudiness.
Okay.
So extremely high levels of solar radiation were recorded.
Perfect.
Well, depends on how you see it. We need cloudiness, of course.
Okay.
From place to place, that might change due to climate change, for example, towards one or the other direction. But still, we're not sure if we are going to have more clarity or more clouds. So it depends, I suppose, on where you live.
Also on my side, I have are we able with the current technology, for instance, to store energy? So one for instance, great day, we can accumulate energy and use it, for instance, when a day it's not as clear as the previous one.
I think that European Union spends a lot of money towards for research towards this direction. Because, for example, yes, there might be a day when solar energy reaches very high levels, and it covers the needs of the grid and 100% more, for example. And then other days that covers only 20%. So, yeah, of course, it could.
And this is actually something that also connects to electric cars. A lot of people ask, what do we do with the batteries when the car is too old and the battery is not strong enough? And I hear from a lot of electromobility conferences that these old batteries can actually be used to accumulate some energy on sunny days, so you can store some energy for later.
Yeah,
So that's some
we love this
opportunity.
cross-fertilization and
Right.
making sure that we are circular. So that's,
Right.
I didn't know, but interesting. So
It is. And what is the number of photovoltaic installations in Greece? Like you said, it's 1.5% in Poland. How much?
Okay, I don't want to say a number because I might be wrong.
Right.
I think that they cover right now less than 30%, but still I cannot. I'm not sure about the number.
Yeah. But it's much bigger anyway.
Yeah. It's, well, of course, because I mean.
Because you guys
Yeah.
are lucky with sun.
Yeah, that's true.
Let's be honest. Okay. So.
also, maybe just another little question on my side. I was very curious to understand, like whether, for instance, like the application of solar panel in building. So
Yes.
this can generate like energetic independence of the building itself, or would always be needed like something else. So if the appliances that we have at home are, for instance, electrical,
Yes.
can we have like an energetically independent home, like just by applying panels?
I'm pretty sure that yes. Well, still depends on where you live, right? I mean,
Yes.
depends on the available radiation. But the PV technology is continuously increasing, and the storage systems are increasing. So I believe that at some point it will be feasible everywhere, at the scale of a house, right?
But also, Elias, this kind of applications, they would be most used by which kind of users? Like, who are you targeting?
Well, okay, right now, many types of users. For the purpose you said before, I think that public authorities, because they will be able, for example, right now in Greece, they, for example, say that more or less we have 20% of power getting into the grid. But in sunny days, it could be 50. The additional 30 is not being used. But with, if the forecast is used, then that the additional 30 can be also integrated in the grid, because the power from other sources will be decreased, so that.
Right. So like you can plan for the local power plant to go a little bit down on the next day, because you guys are expecting that a lot of sun will come to households.
That's the point, and that's the meaning of this application, actually.
Yeah.
And in times of this energetic crisis, I think it's quite interesting to understand like what we can use as an alternative, and perhaps hopefully in the future as the actual energy, like for our cities.
Well, this is a very big discussion, and I believe that.
Yeah, let's not open it here.
Yes.
Oh, you have a question.
Hi, yes, thank you very much. We were saying that before, one of the main community exactly is public authorities, and we know that you co-design already with some public authorities in Greece and all of this, but what's the biggest like barriers right now for us if we want to uptake, for example, within these communities? Because they're pretty difficult to interact with.
Yeah,
I mean, there are so
know.
many little barriers that we said before, so if we want to support you, for example, in the uptake in these public
companies, for
authorities.
example, I'm sorry, I can't, I don't have the words. Companies that are in charge, for example, of PV installations and are in the intermediates, they can use the forecast in order to inform the producers, so they can earn, for example, from this energy.
So it's mostly about, no, mostly, it's also about like the companies that are managing the energy power grid.
Exactly,
So,
that's yeah.
okay. Level, yes.
Yeah. In my opinion, these are the main stakeholders right now.
Yeah.
That's.
It is a very exciting moment when you think of when we learn to predict the weather, and we really learn to take the right conclusions, that we can make our systems more effective, and that there will be more environmentally friendly, also because of being able to forecast what's coming.
Well, yes. I mean, but this is a progress that humanity has achieved. I mean, even with the weather. If you remember weather forecasts,
Important.
I'm forecasting that everybody's
Willing to have a coffee, right?
body pressure will go up. I wanted to say that we cross our fingers for your research because it's so important, and we're excited to have you, Ilias. Annalisa, so thank you so very much for co-hosting this part. It was a pleasure.
It was my pleasure, my honor. Thank you very much. And again, like after the coffee breaks, we will be back with a wind energy session. So, I mean, we come back in a few minutes.
Yeah, see you in 25 minutes at 11:25. Thank you.
See you later.
Hello, everybody. This is the Earth Observation Forum, and we've got a guest from Roskilde, Denmark. It's great to have you, Meret. So Meret will be present with us in the later part of this session. Meret Badger, is that a good pronunciation?
Yeah, that's fine.
Okay, I'm glad. So Roskilde, to me, honestly, it reminds me of a city that has a wonderful festival, that has a music festival.
Yes, it's also a Viking town, so you see Viking
town.
ships around and cathedral.
Are you a fan of Vikings?
Not really. I won't promote the Vikings here, I think.
Right. Right. Why not let bygones be bygones? But I'm curious about the music aspect of your city. Do you think that it's a big part of your, not just the city, but also how people see it?
Definitely, and it is a huge event. People come from all over the world to join it, and everybody in Roskilde joins in one way or the other.
So many times when you hear about, or when you tell somebody about Roskilde, it's probably the first impression.
Yes.
Okay. So it's great to have you. You were born and raised in Denmark?
Yes, indeed.
Okay. What brought you to these topics, Earth observation?
I'm a geographer by training, so I always had an interest in mapping and seeing the spatial picture. Combining that with renewable energy, I think, is the perfect match for me.
Was there maybe a family connection? Somebody was also passionate about maps and like going into places, or it was just your thing?
I think it's just my thing, and traveling has helped as well.
Yeah.
Seeing the rest of the world, and now we see it from above.
I'd like to hear about your perspective, because I'm not a geographer like you, and whenever I go somewhere in the city, even in my hometown, I find myself using Google Maps a lot, and I sometimes am afraid that it makes me silly or dumb, and that is because I tend to turn off my brain, I'm afraid. Do you always use your own map, or do you also use apps?
I also use apps.
Okay.
And my field of research is offshore wind, so out there we don't have a lot of maps.
Right.
Anyway, so it helps a lot to have the satellites.
Right. Have you heard of Poland wanting to be bigger in offshore wind?
Yes, definitely.
Have you seen some tangible signs that Poland really is moving forward, or have you just heard declarations?
Just the declarations.
Okay.
I think there was one in September where the Baltic countries got together and made plans. So let's see where that will take us.
Yeah, let's see. I'm really curious. So Meret, thank you for being with us. Please take a seat, because your presentation will happen a little bit later.
Yes, thanks.
Thank you. So indeed, we are in this wind energy part of our conference. Hello, everybody tuning in from around the world. Whenever you have questions, please always make sure to share them, because this really is about your participation, and it really is about us facilitating this and just making it enjoyable. So this is our Earth Observation Forum, and this time we will hear from the Institute of Meteorology and Water Management, National Research Institute. That's with Mr. Adam Jaczewski, and I hope that he is joining. His team is actually mentioned here, but Mr. Jaczewski will represent the whole team to talk about changes in production, local microclimate and forecasts with machine learning methods. Machine learning seems to be like this buzzword of recent months and years, maybe even, but in here it really does work miracles. Great to have you, Mr. Jaczewski. Thank you for joining us.
Good morning, everyone. Thank you for the introduction.
Is this your little forecasting station where you're located?
No, it's not. It's my house.
Yeah, it looks cozy. I was just tricking you, but I can imagine that these days a lot of very useful software can actually be in your laptop or even in your smartphone, right?
Yes, I have also a smartphone. I can see if everything is working in the stream.
I'm glad. Thank you for joining. We're giving you about 15 minutes, if that's okay.
Thank you.
Thank you.
Good morning, everyone. My name is Adam Jaczewski. As it was said, I'm from the Institute of Meteorology and Water Management, National Research Institute. The subject of my talk is wind energy, its changes in production, local microclimate, and forecasting with machine learning methods. The work in part was carried out in collaboration with the Wrocław University of Science and Technology. I have one question. Are the slides changing?
Yes, sir. If you could just speak a little bit louder,
Yes.
that'd be perfect.
Okay. Okay, thank you. This presentation is divided into the following topics. My first point concerns the importance of extreme meteorological conditions for the energy system. Secondly, I'd like to give you an introduction to numerical weather prediction. Then I will consider a numerical weather prediction model as a tool for wind farm simulations. And finally, I will show the results of machine learning in forecasting in energy production. Is the voice okay for you?
Yes, sir.
Okay, thank you. I want to address the problem of extreme events in the energy system in two opposite cases. The upper figure shows a few days when renewable energy sources fed the system to a small extent, and the lower chart represents the case when the energy production from that sources was very high. This is not up for debate that the main factors influencing the output from that sources are connected to weather conditions. I'll begin by filling you in on the background to give you an overview of the weather modeling systems. The atmospheric phenomena occur at various spatial and temporal scales, and different types of models solve physical processes at different resolutions and forecast horizons. Global models provide forecasts for the globe and the most extended lead time. The mesoscales and regional models operate on 2 to 15 kilometer scales and give predictions for up to 5 days. Nowcasting systems are suitable for smaller scales and shorter lead times. The computational fluid dynamics models resolve physical processes at the scales of order few meters and ultra-short forecast horizons. Machine learning methods can be seen as statistical tools for processing output from physical models and observations. The global or mesoscales model area is divided into layers, usually covering the stratosphere, troposphere, and atmospheric boundary layer. The state of the atmosphere is described by parameters defined in the nodes of the discrete spatial computational grid. Modern horizontal grid is divided by the spacing between nodes. Atmospheric processes that occur at subgrid scales cannot be resolved explicitly and are parameterized. These processes are solar and terrestrial radiation in the atmosphere, land and sea surface characteristics, mechanical transfer of heat, moisture, and momentum. Earth's surface interacts with solar radiation. The resulting surface energy balance depends upon surface albedo, availability of water to evaporate from the surface and its vegetation, roughness of the surface, surface type, presence of snow, and other characteristics. Close to the bottom corner, right corner, is an example of the condensation of water vapor. It's a result of collisions of water droplets and the release of latent heat of evaporation. Condensation occurs in the small subarea, 1 kilometer of the cube mesh of the mesoscale model, but the droplets are many orders smaller. And then we have to parameterize these small subgrid processes existing in small scales in the model, which has a resolution of, for example, 2-3 kilometers. The Institute of Meteorology and Water Management is a Poland national weather service and member of the World Meteorological Organization. We provide weather predictions based on different numerical models nested in global systems. The models are developed within the framework of the European Weather Modeling Consortia. Additionally, we utilize the open source weather research and forecasting model developed by American institutions and the worldwide community. This model contains different additional modules dedicated to specialized applications. To achieve high resolution simulations, the model runs are repeatedly nested to cover a dedicated area. This is an example of such nesting. So the main domain is part of Europe, Central European, and a medium one is covering Poland. And the last one, with high resolution of half of a kilometer, is in the part of Baltic coast. One particular application is wind farm parameterization, which describes wind farms' interactions with the atmosphere. It is essential as the interactions occur in a wide range of scales from thousands of kilometers. It's here, mesoscale and microscale. From thousands of kilometers to millimeters. It's here. It's airfoil scale of wind turbine. And near the bottom right corner is an example of wind field and potential power simulated by the model near the Baltic coast. Wind farm simulations require a vertical resolution of 10 meters to a height of several hundred meters, and the inclusion of the turbine turbulence options to allow for the wind bursts necessary to vertically mix the air and achieve the expected warming and drying of the surface. In this part of my presentation, I'd like to describe the results of our work published in 2021. 4 machine learning methods were used to simulate energy generation from wind turbines installed in Poland. The wind speed forecast from the numerical weather prediction model, energy generation, time series, and localizations of wind turbines in Poland were used as input data. On the right hand, you have figures with mean absolute percentage error for these 4 machine learning methods. For all models, the lowest accuracy is yellow color, represented by higher mean absolute percentage error, is presented in June, while the highest occurred in January and February, dark blue color. Between 0 and 8 UTC, all models produced more accurate wind forecasts. The AN model had the lower variability of MAPE during days as well as the whole year, while the XGB model had the highest differences between lower in January during nights and high error in July during days. For hourly data, the best results were obtained with the XGB model with MAPE equal to 27%. The AN method with MAPE equal to 14% was the best for daily zoom. Finally, I'd like to highlight the benefits of using numerical weather prediction modeling in the wind industry. First, it supports the logistics of wind farm construction by studying local climatology of the wind field, determination of the optimal location of the farm, and choosing a turbine type. For the operational activity, the weather prediction can be used to optimize network performance, improving the efficiency of energy production, and transfer forecast energy production. Assessment, and last but not least, numerical models may support the assessment of the environmental impact of wind farm by investigating turbulent effects or increases in noise levels. Thank you for your own. Thank you.
Thank you very much. You could probably hear the applause from our audience. We're very
Thank you very
thankful
much.
for your presentation. I'd like to see if there are some people who'd like to ask their questions. I don't quite see that yet, but we have this situation when I can also check the internet, so please just give me a few seconds. We do have some questions, but they have to do with photovoltaics, which I don't think is your specialization. So can I just ask you, did you just, I wonder if you could be here with us, because to be honest, I just lost your image.
Yes, I am.
You are
yes,
back.
I am.
I'm glad. So I wanted to ask you about the part that your institute plays in all of this. What is the goal that you're trying to achieve?
The problem in wind energy production forecasting are weather conditions on different scales. And we started from.
Sorry, I didn't catch that. What's the problem? Can you say that again?
Yes, the problem is with forecasting of weather conditions. Okay. So it's necessary to forecast these conditions exactly for hours and consecutive days, next days. And so we started from this one publication, and we think there is potential for that applications in Poland. Mm-hmm. We have access to input data, and we are now developing the methods and are looking for more accurate data for this to make good forecasting.
Okay, and why do you have this special layer of like this special scope for Gdańsk region, like just at the seaside? Because I've seen that you treat it in a specific way.
Yes, yes. So this part is very important for offshore wind farms. Mm-hmm. Because the wind farms are planned to be built on the Baltic by different companies, Polish companies. Mm-hmm. So why we are looking for that region.
Okay, thank you so very much for joining us. And special thanks to your team as well. Please say hi to all of your team.
Thank you.
Thank you. We'll now be joined by Meret Bajer, the emerging offshore wind products specialist from Roskilde. She's the senior scientist, Department of Wind Energy, Meteorology, and Remote Sensing, Wind Energy Systems Division. Meret, great to have you.
Thank you so much.
I wonder, Meret, how much of, it should work. Yeah, it does.
Okay.
I wonder how much of his presentation was something that also spoke to you that's somehow similar to what you do in Denmark.
It does speak to me, but I think we complement each other well, mm-hmm. because my focus will be entirely on Earth observation data and how we can use them for offshore wind. This was about numerical modeling, and both are important and valuable data sources.
Do you think that offshore will really take off in Europe soon, or has it already?
It will.
It will.
It has in the North Sea, but it will expand. I will also show that when my, I guess I can.
Wonderful. Thank you.
It's actually one of my opening slides. We have a pilot in E-Shape called Merging Offshore Wind Products, and it's about using different types of data in synergy, because we know that there's not one type of data that can uniquely solve all the challenges we have when it comes to offshore energy. Every data set has its pros and cons. So here's the slide I mentioned. The European Commission has really ambitious plans for offshore wind energy going up to 2050. We should install 450 gigawatts. Today we have around 11 or 12 gigawatts installed in Europe. So it's a massive amount of energy that is expected to be installed in the coming years. And I've circled here the Baltic Sea because that represents a large fraction or large share of this expected installation with, I think, 83 gigawatts. And the question is then how to find the best places for the wind farms. We need to find the places where the wind is strongest. We normally speak about the annual mean wind speed, and we want to find the places where we have the best wind resource. So there are various data sources we can use. We can mount meteorological masts or LiDARs on ocean buoys. They will measure in a single point. They're quite expensive to install, and they're also difficult to maintain in the harsh marine environment. And when we get to water depths over 60 meters, we can no longer mount bottom-fixed installations. Then we have the numerical weather prediction models that can give us outputs every hour, and that's wonderful. But we have to always remember they are based on calculations, so they're not always accurate. We spoke about weather forecasting before, and everyone knows that a weather forecast is not always perfect. So let's look at the EO-based products. We can retrieve wind fields offshore. We have 20 years of satellite data available for us in the different archives, and we can do this with a high spatial resolution. The shortcoming is that the temporal resolution is much lower than what we can get from in situ measurements or models. And the winds we can retrieve are valid at the height 10 meters above the sea surface, but wind farms are operating at much higher, maybe 100 meters, so we need to combine with other data sets to extrapolate the winds to the turbine heights. At the Technical University of Denmark, we use two types of microwave sensors to retrieve wind fields. One is synthetic aperture radar. Currently, we have access to data from Sentinel-1. We also use ASCAT, and the scanning principle is the same for both types of sensors, but there's a large difference in the temporal and spatial resolution. And for ASCAT, we can get readily available wind products, whereas for SAR, we have to retrieve the winds ourselves. It's very important to understand that the winds we can retrieve offshore are really based on observations of the sea surface. To the left here, you see a picture of the sea surface when there's little wind, and the sea surface acts a bit like a mirror. So a radar pulse sent from the satellite will be reflected in a different direction than the direction it came from. When the wind is picking up and we start to see lots of waves at the sea surface, there'll be more interaction between the radar pulses from the satellite and the waves, and the waves are generated by the by the wind. So we can make relationships between the instantaneous wind speed and the backscatter signal that the satellite can measure, so the amount of radar pulses that are returned to the satellite. I will not go deeper into the technical details of this. I'll just tell you there is a relationship between the radar backscatter and the wind speed. It involves radar geometry, the viewing geometry, and the wind direction as well. But we can retrieve the wind speed based on this. So here are two examples. The left is from the UK, where there are quite many wind farms, and this is on a calm day. So you can see we just get a blue image, not really much going on. And we can see the wind turbines clearly because they act as what we call bright targets or hard targets. So they reflect a lot of radar backscatter directly back to the satellite. But this has nothing to do with the wind, really. This is just to illustrate that we have to have a certain wind speed, around 2 meters per second, before we can start retrieving the winds with good accuracy. So to the right, there's an image from Scotland where there's a lot of topography. The wind is coming from the west, so the left in the image. And we can really see a lot of details. So the color is the wind speed, and we can see how it varies. We can see these wavy patterns. That is real wind speed variation created by the mountains in Scotland. So this is, I think, quite fascinating that we can see this kind of detail. These are real observations of what's going on. Here's a very recent example from the South Baltic Sea. It's from the 6th of November. The wind is from the south in this case. And you can hopefully see also the variability in the wind speed. And of course, it matters a lot where you place a wind farm here. This is just one snapshot. But you can really see that there's some blue areas with low wind speeds in the lee of the land. And there's some yellow areas where the wind speed is higher. So this is important when we want to extract energy from the wind. We have done many studies where we try to quantify the accuracy of this technique, and we find that we can get a root mean square error around 1.3 meters per second for the wind speed. So when we compare with other data sources like ocean buoys, in this case, we get a reasonable agreement. It's not as good as a mast observation with an anemometer, but what we get extra is the spatial, the image, the spatial picture. And we have to compromise a little bit the absolute accuracy. So in eShape, we have built a service. We call it the SatWind service, and I put the URL for it here. So here you can go in and browse our archive. We have around 500,000 wind maps at the moment. Many are over the European seas, but we have also expanded to other areas. And we put the data up in near real time, meaning within 24 hours from the data acquisition by the European Space Agency. So it requires quite a strong processing chain and HPC system to always download and process the latest data as soon as they're available. So if you have time, you could have a look and browse for yourself and see what's in this archive. And you can also, if you register, you can download the images for free. And now a few examples of use cases of this archive of wind maps. In the North Sea, where there's already many wind farms operating, we can study the wake effects. That's the way that wind farms impact their surroundings. Maybe you can see here that the wind is coming from the land, and I don't know if I have I do have a pointer. Maybe not. But you can see here there's a wind farm here, and a dark shadow behind it. The wind is coming from here. And you can see this shadow really goes for quite many kilometers downstream. Sometimes it's up to 100 kilometers. And of course it matters now that we have many wind farms out there. They start influencing each other. So one wind farm can take the wind from its neighboring wind farms. And the SAR-based wind maps are really excellent for viewing this. We can really see what's going on out there. And there's more and more wind farms in construction in this area, so the problem will be more and more pronounced over time. We've also had the opportunity to validate this against ground-based Doppler radar observations from the wind farm developer Ørsted. So the two images to the lower right here are the ground-based measurements, and we can see a lot of similarities with this satellite-based images to the upper left. We can also see that the resolution of the SAR is coarser than what we can get from a ground-based sensor. But of course, the advantage is that the EO data is there. We don't have to do anything to get the measurements other than downloading the data. Another application we spent quite a lot of effort on is making wind atlases. And the wind atlas can be seen as a statistical analysis where we take all the satellite images we can get and put them together, stack them on top of each other and calculate different statistics. For example, the mean wind speed or the wind power density. And these maps are also available on our website, and we update them each year. So you can get maps for all of the European seas at the moment. And here's just another version of those European maps. And you can see to the left, there's a map based on SAR data, and to the right from ASCAT. So they are similar, but you can also see that the map to the left has more variability, more details, whereas the ASCAT map is quite similar in scale to the numerical models. So you see smooth curves, smooth contours in the map. This is a mean wind speed at 10 meters above the sea level. We can also extrapolate to 100 meters. I don't have time to go into detail of how we do it, but the trick is to combine with numerical models to get wind profiles. And we then see that the mean wind speed has increased a lot as we go up, because that's what happens with the wind. It gets stronger as we go up in the atmosphere. We've done the same thing in the US, along the US East Coast, and here we show a comparison between a satellite-based map and a model-based map calculated from WRF simulations. Again, we can see a lot of similarities, but we can also see that the satellite provides a lot more detail of the mean wind speed in this area. And why am I showing this area? That's, of course, because ambitious plans in the US as well for the installation of offshore wind farms. You can see them in yellow on this little insert map. So as part of eShape, we have worked with co-design, and we have been in contact with 3 types of users. One was from a small consultancy company. Another is from a company that provides model simulations. And the third is from the big developer Equinor. And we have interviewed each of them and talked in detail about their requirements and how they see our website and the products behind. And many interesting things came out of those conversations, and it was really great to take the time to talk to the users. One of the outcomes of that was that we improved the documentation a lot, because we saw that perhaps the biggest barrier for using our data sets is that the industry is a little bit skeptical and not sure about the trustworthiness of the data sets. So we have put in a lot of documentation and references to our research so that they can really get to the bottom of it and understand the accuracy and the issues that come with the EO-based winds. Another thing that has come out of this dialogue with the end users is that we have expanded our area of interest. In the beginning, we covered the European seas, and that was hard enough to keep up with the processing for that area. But during eShape, we have expanded to also cover the east coast of the US and the Great Lakes, as well as the seas of Southeast Asia. And we've chosen exactly those areas because we know from the industry that these are the hotspots for offshore wind energy development. There's really a lot going on in those places at the moment. So just in summary, I want to really highlight that EO winds are available for the last 20 years, so we can go back in the archives. We don't have to wait for a mast to be installed or a LiDAR to be mounted. It's all available at our fingertips. The EO winds have a higher spatial resolution than mesoscale models, so we can see details that are otherwise not really visible to us. And we can cover large areas like I showed. The temporal sampling is reduced compared to other data sets, but it is improving all the time. And maybe one of the latest news is that these really small nanosatellites are being launched at the moment, also with SAR sensors on board. So we can start getting much more frequent sampling, maybe even hourly sampling at some locations in the future. So the future looks really bright when it comes to the temporal resolution. And as I mentioned, the 10-meter reference height requires that we combine with other data to extrapolate to the wind turbine hub height, which can be over 100 meters. So we believe that our archive is useful and can guide the industry to some further steps, for example, to decisions about where to install a buoy or a mast. It can guide them when it comes to their numerical model simulations. Are they correct or not? And we can see the wake effects very clearly, and that can help the planning of future wind farms. So basically, there's a lot of decision-making steps where potentially these maps could be very useful. And just to get back to the agreement, I found this piece of news that the Baltic ministers have signed this agreement for closer collaboration on offshore wind energy. So maybe, or hopefully, that will be a basis also for some of us to collaborate in the future, find new projects and funding opportunities together. That would be wonderful. So that's the end of my presentation.
Thank you so much. Do we have any questions? Oh, we do. So Annalisa has one, but a gentleman over there has. So Agnieszka will help that. Hello.
Thanks for a great presentation. You've actually answered most of my questions that I've had throughout the presentation. So it's really great to see a project that really works in real world. So my only question is regarding the different locations that you presented at the very end of your presentation. And I wonder if you managed to develop one model that is universal for the whole world, or these are site-specific models that specializes in like Northern Sea or...
This is universal, so the only limitation is how much data can we download and process. And I think in the future, cloud computing will also help us when it comes to that. But it is the same model. And to go a little bit deeper, I can explain that the geophysical model functions we use for the wind retrieval are developed for scatterometers, and scatterometers already cover the entire globe. So they are made for global wind mapping, and we don't do any specific tuning for the different areas we investigate.
That's quite impressive, I think. Thank you. It was very great.
It is very impressive. There's this margin of error that happens because some of the wind that you measure can be in fact somehow copied. Like it's not actual wind. That was part of your presentation as well.
Yes, there are many sources of error potentially. One is what I showed, that if the wind speed is low, we don't really get a signal. There could be other factors at the sea surface, for example, algae blooms or oil spills, anything that modifies the small-scale waves at the sea surface will have an impact on our observations because it's the small-scale waves that the radar observes.
Mm-hmm. Annalisa?
Thank you very much. Thank you, Merete, for this very interesting application.
I think one really close area could be meteorology in general. So validation of the numerical weather models is one example. Then we have talked a little bit also about windsurfing, and we talked about sailing last night, that sailors are really also interested in the details and knowing exactly how the wind blows in a small area. So I think that could be a potential application that we could... Okay, so maybe we can try
exactly.
to...
And thank you for that. And indeed, I am happy to contribute. But also, other two questions about the offshore wind farms. So, in your research, did you also take into account, for instance, environmental impact of placing and installing the wind farms? And is there also an economic impact, for instance, which means for the fishermen and for people that are going out at sea and that they found a wind farm? So is there any kind of impact of this kind of installation? And last question is about...
I could even imagine that they be angry sometimes because it makes their life harder somehow, right?
Yeah, that's sometimes the case. I can maybe explain a little bit how it works, at least in Denmark, and it is different from country to country. But in Denmark, there's a process where a developer needs to do an environmental impact analysis to get the permission to move on with the project. And during that analysis, all aspects will be analyzed, not just the winds, also the waves and the mammals, birds, fisheries, anything. So that's how it's done in Denmark, at least. And I know that at the European level, there's some new requirement for these marine spatial planning reports. I'm not expert in it myself, but I know the countries are developing these reports to kind of map the resources offshore. So some resources or some areas will be devoted to military, some to shipping routes, some to mining, and there are different interests offshore that all need to be balanced.
And so probably some spatial planning will have to come into play because it can get pretty busy out there.
Exactly, yes. But there are initiatives and activities. It's not really something we do research in my unit, but it's happening at the moment.
No, but just to conclude, so I believe that those data also for people that are working in the maritime special planning, so organizing indeed the different zones are very useful because they might know where to install it and how to consider this kind of other factors.
Yes, yeah, definitely.
Thank you very much.
When we were listening to your presentation with Francesca, we were wondering about, is there a potential of somebody taking somebody else's wind somehow? Like if you build a new wind farm next to an existing one, can you put them in a really hard situation?
Yes, that's what we see at the moment. And sometimes these wind farms are owned by different developers, different companies. So it's already happening. And the density is growing all the time, especially in the North Sea. So it will happen more and more.
Yeah,
I don't know, actually. I think that's a little bit beyond my...
So Francesca just asked about conflict
field.
resolution, because at some point it probably will have to be there.
That's the usual answer of scientists. That's not my business.
Scientists don't want to know. Well, lawyers would say it depends, because they always say it depends.
Yeah, I'm afraid I can't answer that one.
Yeah.
I haven't really heard of any... whether there are some cases going on already or not.
But it probably will be more frequent. Because from a scientific point of view, is that very common? Is it a real threat that if you have this wind farm, that it actually really takes that energy?
Yes, that is real. Yeah. That is happening already.
And you said
today.
it's like for almost like hundreds of kilometers?
Yeah, it's not always like that. It's under certain wind conditions, certain wind directions and wind speeds that we see it very pronounced. Other days it's not a problem, so it depends a lot which way the wind is blowing, of course, and also on the wind speed.
Thank you. Are there some other questions? Okay, it was really interesting listening to you, and thank you for a great presentation.
Sure. Thanks.
And now this will be with Maciej Christian Yefimov. He's the chair of Environmental Protection Faculty of Building Services. Hydro and Environmental Engineering. He works at the Warsaw University of Technology. Great to have you, sir. I believe the topic of your presentation is the next 100 years, isn't it?
Hello, hello. 111. Okay, can you
Hi.
hear me?
So you also into predictions. You were, well, you don't call them predictions, you call them projections?
Projections, yes, because, well, if we're talking about the climate, we're talking about the longer distance in temporal scale. We call it projections.
What did you think of this discussion about energy, wind farms, taking energy from one another?
It's kind of surprising, but at the same time we can see similarities with different sources of energies like heat from the earth that can be stolen from another.
Like thermal?
Yes, thermal. Something like that.
That has happened before?
I'm just assuming that this could be the case, actually.
Because nothing is infinite, right?
Yes, of course.
Wow.
And the similarities...
It's getting really complicated here. Yeah.
Yes.
Mm-hmm. So let's just forget about that discussion.
Of course.
Let's not get too stressed. And let us greet our next speaker, please.
Okay. Thank you very much for this wonderful invitation. I wasn't expecting that. So my name is Maciej Efimov. I work in the Institute of Environmental Protection, and as it was announced also, I work as assistant professor at the University of Warsaw University of Technology. And for the purpose of this presentation, I have prepared a topic that is entitled, as you can see, calibration of the climate projections up to 2100 for Poland using satellite-based observations. Okay, so in the beginning of this presentation, I would like to share with you a summary of a project that this analysis is derived from. So the project is called the Knowledge Base on the Climate Change and Adaptation Strategies for Poland, in shortcut Klimada 2.0. And within this project, we were aiming to create a coherent information for all administrative regions. In Poland, it's powiaty, of course, counties, if you will. And so that the results would be publicly available for free for all, and that they would serve a diverse applications, like, for example, for adaptation plans, environmental impact assessments, sectoral development plans, climate protection, research and education, and so on, of course. And for this project, we used climate projections from Eurocordex repository from the domain Euro 11. This is how it's called. It's a domain, as you can see in the right section of the slide, with the resolution 12.5 kilometers square. And with our methodology, we assumed that we will not exclude any model that is available at the time that we were working with that. So we were not excluding, not rejecting any model that could be used. And we choose two different realities, let's say, two different paths that can be that we can witness in the future, RCP 4.5 and RCP 8.5, derived from the IPCC 5, with the time span from 2006 to 2100. And these Eurocordex data are actually a downscaled European projections of the global climate models, CMIP5. For the purpose of our calculations, our analysis, we choose the daily data for our indices that we were providing. So in terms of the scope of the project, we were analyzing many different parameters: average daily temperature, maximum daily temperature, minimum daily temperature, solar surface radiation, sometimes called irradiation, precipitation, wind speed, snow cover, relative humidity, and total cloud cover. We calculated over 50 indices for climate parameters, 55, and 5 indices for energy production potential. Here in the right section of the slide, you can see an example of a visualization from our calculations, the anomaly of average monthly temperature for the RCP 8.5 scenario relative to the period that we call the current climate conditions in our analysis, so period from 2011 to 2020. As you can see, it's drastically increasing in the future, of course, in this scenario. Yeah, and to perform the calibration, we need, of course, the observation data. And we wanted to have as wide ensemble as possible. Therefore, we calibrate each model with different set of data sets. For example, the gridded ground station data that are mapped on the gridded maps, like you can see in the right side of the screen, provided by the Institute of the Meteorology and Water Management, and also EOPS data, quite popularly used in Europe in climate studies. We also use various reanalysis data, like ERA5 data, ERALAND, or WERA. And of course, something that is interesting for the Earth observation, we also use the satellite data products. Satellite data products like SARA-2, and regarding the total cloud cover from EUMETSAT provider. Here in the right section, you can see also comparison between the 3 different data sets. In the top section, there is a summarized average sum of surface solar radiation for ERA5, and at the bottom you can see the same for SARA-2, and in the right section you can see the ground stations that are interpolated into the map. You can see that there is not big disparities between the reanalysis and the satellite data, but in comparison with the station data, unfortunately, some differences can be visible. But in case of our studies, when we average data over a long period of time, these disparities just simply disappear. So, going into the detail regarding the satellite products that we have used, we used total cloud cover from the Satellite Application Facility on Climate Monitoring. They are using a polar orbit satellite from NOAA plus EUMETSAT with the sensors that are listed here, and they are providing a global data on a regular grid with a spatial resolution of 0.25 degree and with temporal resolution 24 hours. And in the right section, in the top image represents this product. And regarding the surface solar radiation, we use, of course, the same provider here, but in this case, they are using the geostationary Meteosat satellite, which uses these sensors that are listed here. And they provide a product called SARA-2 with the spatial resolution and temporal resolution the same as the total cloud cover. So these are the satellite products that we have used for our calibrations. Now, regarding the analysis itself, before we proceeded to the calibration of our models, we compared the data with each other. And as you can see, in case of the monthly data or yearly data, these disparities are, there are some disparities because they usually between the ground stations and the satellite stations there are visible. But in case of our analysis regarding the climate, these disparities will simply be neglectable. Here, in both scenarios, after the calibrations, with usage of different observations, the models, or let's say partial ensembles from the models are almost identical in terms of course, annual data here. And this is, of course, for the surface solar radiation. Regarding the total cloud cover, you can see the similar case. So there are some small disparities regarding for the, especially the hot months here in August, especially. But these kind of differences are also neglectable in terms of the yearly averages and in terms of decadal averages that we have worked with. So the calibration of modeled data with usage of this satellite observation is slightly higher than the ERA 5 for annual data, but our final ensemble here was created in form of an average of these two, so it is visible in between those two different data sets. In both cases, in RCP 4.5 and 8.5. So to the procedure itself, so in the right section of the slide you can see selection of images comparing what was happening before the calibration and after calibration for the models. And we proceed this kind of calibration for each of model that we have used and with all the data, all the observations that we were able to use in our project. The red color represents the model after the calibration, the blue before the calibration. Please look at the bottom part of the slide and see how big bias it was before the calibration. The black color, I believe, is the observation here. I hope that it is visible. This is, of course, for the total cloud cover. So in order to reduce this systematic bias for each model output, we perform a statistical correction that is called quantile mapping, a non-parametric approach of robust empirical quantiles. And it was called ERQuant. It was performed with an usage of a quite useful tool called QMAP library from R. And we performed this correction to each grid point in our domain, in our models. And to explain this procedure, if you search for it in the literature, you will find something like that it attempts to find a transformation of modeled variables such that its new distribution equals the distribution of the observed variable. So if we assume that P0 is observation, PM is model, we are searching for such a transformation H that will approximate this value of observed value. And according to Gudmundsson and al., solving this equation number 2 will allow us to perform this procedure, where Fm is the cumulative distribution function of modeled values, and f0 to the -1 is the inverse cumulative distribution function, or the other word, quantile function corresponding to the observation. And to solve this second equation, we perform the empirical approach with tables of the empirical percentiles, where the values between the percentiles are approximated by a local linear least square regression. So these are the results that we have achieved of our final ensemble after averaging over all of our models. In the left section, you can see the decadal maps of Poland for the surface solar radiation. In the right section, you can see the plots suggesting the trends that we will be facing. Again, the total cloud cover, similar case. In the left section, you can see the decadal maps. In the right, you can see the trends and stripe plots. So, summarizing, no big disparities can be noticed between the different observation data sets in terms of solar surface radiation. Small differences can be seen between ERA5 and satellite data in terms of the total cloud cover. All as a result of the statistical correction, the bias between the model and observation was reduced, and so on. And finally, a decreased trend of solar surface radiation can be partly explained by an increase in total cloud cover in scenario 8.5. Thank you very much for your attention. I hope that I didn't extend.
No, you didn't. It was good. Thank you, sir. And let me take a look at the people in the room. Is anyone interested in asking a question? We have one person.
Thank you for your presentation. My question is if you take into account the air pollution while it's just cloud cover. Because I'm asking because of the impact of global dimming, brightening on solar radiation, and then it's neglected in this
I understand. Right? I actually expected this question because aerosols in general are impacting the formulation of clouds, of course. But these models, unfortunately, did not have any other parameterization than the climate approach to the aerosols, as far as I know. Therefore, dynamic aerosol probably is not included in them. So the formulation of clouds, I believe, or is contributed by the increase of the surface temperature in the future here, and the convective movement of air.
Thank you for the question. Any other questions? Oh, could you pass the mic, please?
Do you intend to update your results for the CMIP6 project?
I also expected this question, actually.
The first one I thought was this one.
Yes. Yeah. There are rumors that maybe we will be updating that, because this is, of course, IPCC5 scenarios that are currently outdated. Some people say that they are quite outdated. So,
are they some informed rumors?
I don't know. I cannot say. I'm not the decision maker in this project.
Yeah.
Unfortunately, but
sorry, one more. I'm mainly asking because if I'm not wrong, in the next Eurocortex, the air pollution, which is not included, if I'm not wrong again, in these simulations, will be included. So it would be interesting to see what changes, especially regarding future.
Exactly. Yes. Thank you.
So yeah, we're also hopeful about that. I was just really puzzled with your slide where you show that the numbers that come from satellite Earth observation when it comes to the amount of solar radiation that comes into Poland is so different from what you guys have. and I don't know whom I can trust.
You mean the differences between the satellite and the ground-based
Right.
observations?
It was pretty different.
Yes, because the ground-based observations are like on the spot, on the station, right? And we simply did the interpolation of it on a map level. And
do you think there's a chance that in the future these data will somehow be more compatible?
I believe so. I believe so. Well, you can see that in terms of our climate analysis, when we average over longer period, like 10 years and so on, these kind of differences are neglectable.
Okay.
But if you are analyzing a shorter period, like 1 year, for a specific investment or something like that, that is quite important to have a coherent knowledge about the climate observation.
Have you heard about the Deutsche Wetterdienst?
Deutsche Wetter, what?
I think they do the same thing that you guys do, but in Germany.
Unfortunately, I'm not familiar.
But it's okay, because you will just meet a person from there. Thank you for your participation.
Thank you very much.
That is the Department Climate. Department Climate and Environment Consultancy. Deutsche Wetterdienst will be represented by Saskia Buchholz, but also some other people a little bit later. Saskia, are you there?
Yes, I'm here.
Oh, wonderful. You wouldn't believe, but the sound that you give is so clearly audible. I wanted to praise you for your technological advancement, because it will make the interpreter's job so much easier.
Oh, thank you.
Yeah, we appreciate you.
Okay.
I just wanted to ask you if it's okay that you stick to, or you keep your presentation to just 10 minutes.
Oh, okay. That's that's the goal. Okay, so I will start right now.
Thank you.
So we will show you the pilots that we developed in the E-Shape Climate Showcase. And the pilots are to strengthen the urban resilience and the preparedness of the city authorities to extreme weather and climate. And we are using different meteorological data, for example, the sub-seasonal and seasonal climate forecasts and climate projection data. So I would like to start with the pilot from DWD, the German Meteorological Service, and we developed seasonal and decadal climate forecast products for city authorities. Right now, or currently, for our 16 state capital cities and the pilot city Aschaffenburg. And yes, we are using the German climate forecast system. We are calculating 30 ensemble members for the hindcasts, and each month 50 ensemble members for the forecasts. And all the calculations and simulations are done at the ECMWF Atos Boule Sequana high performance computing system in Bologna. And all the post-processing is done on our in-house architecture. And for the global climate forecasts, we also increased the spatial resolution for our German forecasts via a statistical downscaling approach that is called episodes. All our data is available openly on our DWD climate prediction website, which you can see here. And you will find the E-Shape pilot that is integrated in the basic climate predictions. And then you can choose, when you're on this website, the seasonal and climate or decadal climate predictions, where you will find the cities. The user can choose between the prediction month and the start year of the prediction, because we also have a kind of archived data within the pilot. You can also choose the region, so you will get a list about different German regions like Eastern Germany or Southern Germany, and then you also get a list from the 16 state capital cities. Currently available are the meteorological parameters of temperature and precipitation, and for the prediction type you can choose between an ensemble mean prediction or a probabilistic prediction. And we have 3 different types of visualization, which you can see here. On the left-hand side, you can see a map. So you can focus, for example, on the city. Here it's the city of Berlin, which you see. You can also choose a time series visualization, which is in the middle available. And we also present the values in a table visualization. And that's from my side for my pilot. And now I would like to hand over to Otto Hivarinen, who will introduce you the pilot from the Finnish Meteorological Institute. Is he available or?
To be honest, I'm not sure, but
okay, but maybe for the time I skipped the the slide for the FMI, and maybe Maya can take over for the ZAMK pilot.
Yeah, I wonder if Maya is there. Oh, Maya, great to have you, by the way. Oh, perfect.
Yeah, I'm here. Thank you.
Thank you for
Hello,
saving
everybody.
us.
So this part of the presentation is about the future climate projections of heat indices for the cities in Austria. So we are moving on another time scale, and we are looking at heat specifically. This part is done at weather service in Austria, in Vienna. Next slide, please. And what we are developing or producing is the downscaled information of the global or regional climate scenarios on a high resolution, specifically for urban regions, so that we include climate change signal and urban heat island effect. This information is used in spatial planning, so our main stakeholders are city administrations, which develop spatial strategies for development of climate adaptation guidelines, then environmental protection or risk management. Next slide, please. So we are looking at the high resolution maps, which is around 100 by 100 meter, and we use different kind of EO data as input into the model. So information about the land use or city structure. We use Urban Atlas, Copernicus, land monitoring services, but also national available data, also satellite based like Land Information System Austria, which are available on 1 meter resolution. Additionally, we also use the information of height or specific data from the cities. The climate scenarios are based on the Eurocortex regional climate model, which are presented in the previous presentation. So we are looking at the time period from 2000. And as an output, we have climate indices per year, which are typically summer days, hot days, or tropical nights, or in the last days, so desert days, like days where maximum temperature increases over 25, 30, or 35 degrees. Next slide, please. Next slide. Yeah. So the method is developed by the German Weather Service, which combines the dynamic modeling with the urban climate model and the statistical evaluation with the cuboid method. So we simulate particulation when the excessive heat in the city, and then we combine this information with climatic time series from the regional model, and we can develop relatively cost efficiently computation the different scenario, different time periods. So we have developed that for Vienna, and then we extended these simulations for Graz, Linz, Salzburg, Innsbruck, and Klagenfurt. Next slide, please. So the data are available on our national data center, which can be accessed under this link. And the user can see the maps, can download the data in NetCDF format, can check the metadata references, There's also version tracking system and visualization on the map where you can zoom in, zoom out, choose the legend, and also plot the time series for specific locations. Next slide, please. And to make the information more user-friendly or to have more description, what is a pilot about, what is behind the results, we also developed another web page specifically for this pilot, where there is a link to the data download and also links to different kind of data sources that were used in this pilot. Next slide, please. Next slide.
This is the last slide, Maya.
Okay, so okay, there was there's also that you can read about our pilots that was recently published in the FMI bulletin. Yeah, this one.
Thank you very much. So I wonder if we could have both of you on the screen. That's just my question to our team, and I wonder if the missing person might join us eventually, or if it's the two of you. Do you still hear me?
Yes, we can hear you.
Oh, nice. So is the other person joining, or will it just be the two of you?
I guess it's just the two of us. Yeah.
Okay. That is still great.
Hello.
Thank you for staying. We have some extra time now that we know that one person is not joining. I wonder if the two of you could somehow try to summarize what that missing part of the presentation is.
Yes, so the Finnish Meteorological Institute developed for the city of Helsinki, also with a close cooperation with the city authority, a pilot, and they are using seasonal and sub-seasonal climate predictions, and it's for street cleaning in the winter seasons.
How does that work?
They have something like a snowfall and slippery conditions on the streets developed, and yes, this is for the city authorities.
So is it about trying to predict what the weathers will be and then reacting to that accordingly?
Yes, so maybe to better inform the public and also the authorities about the weather conditions and in planning and managing, for example, the street cleaning, like 2 weeks ahead or 6 weeks ahead, like this.
So there are some phenomena, some natural phenomena that you can predict so much ahead. Is that what you're saying?
No, it's more a combination of meteorological variables. So having a look at the temperature and the precipitation and how the precipitation falls as rain or as snowfall, and then calculating and saying something about the weather conditions on the streets.
All right, that's interesting. Are there some questions that we have from the audience? Okay, it doesn't seem like that yet, but I'd like to turn it over to Maya and to ask you about Austria. So is this a cooperation between Austria and Germany?
Yes, we are cooperating already for a long time on this pilot study. So in this case, it was intended to develop future climate scenarios, but the same model can be used to test scenarios for climate adaptation or urbanization. So it's really a very fruitful cooperation.
Yeah. Is there a lot of benefit of doing research together? I know that your countries speak the same language, so it seems like a perfect situation.
Yes, not only that, also sometimes our data organized in the same way. The cities also communicate between each other, so and are built in a similar way. So we have a lot of common points.
Oh, wonderful. Do you agree with that, Saskia?
Absolutely.
Yeah, I'm glad. So the two of you work close together. I wanted to ask about Maya's presentation because if I understood it correctly, you are preparing some scenarios, some visions, and sorry, I lack the scientific way of putting things. I don't know the right words to say that, but you're trying to predict what can be the future climate, what the climate can be in the future in some of the Austrian cities.
Yes, we look at the Austrian cities, but particularly the phenomenon of the urban heat islands. So we look at where in the cities are the hotspots. So this is important information for the spatial planners to know where to put the priorities for the adaptation or renovation, and also cold spots. So there is a climate signal for the future that it will be warmer, but there is also inhomogeneous heat in the city. And this is why these maps are useful.
Inhomogeneous, does it mean that it's not caused by a human?
Well, if you consider that the cities are built from humans, then yes.
Hard.
So yeah,
I
so
just
it is
struggle with inhomogeneous. It's just a tough word.
Yeah. Yeah, but this because we have densely built cities or with less vegetation, more vegetation. So all of them have particular thermal properties, and they are different. So with the climate change, different parts of the city are getting differently impacted.
Right. Are there some interesting findings that you have? Like maybe you could just give us an example of what you've learned about some of those cities?
Well, we see in all cities warming because it is a large-scale signal. So this is what all of them are impact. We have, for typical for Austrian city, it's in a complex terrain. So the local positioning of the city, whether there is a river or a mountain behind, makes a lot of difference on the local climate. This is often not seen in the regional models. So it's very good to investigate on a small scale. And we also see from the simulations that the green areas or water areas have quite different thermal signals. So they are normally cooler than the densely built areas or the areas where have a lot of pavement.
And what about Vienna? This is one of the most livable cities in the world, if not the most livable. It has won this title multiple times. Do you think that when it comes to hotspots and overheating in cities that Vienna is still on the safe side compared to some other cities in Europe?
I think Vienna is experiencing new challenges with the hotspots. There is the problems that were not there before, and there is and it's a very complex system when talk with the spatial planners of all the different problems they need to consider at the same time.
Can you give us an example? Can you give us an example of one of the new issues with Vienna?
Well, we have record number of heat days in the last year that were simply not there 10 or 20 years ago. And it's and then the people are getting more and more aware about the climate change, and the city has been also densified or very urbanized. So there is also possibilities to implement the green infrastructure are limited, or they need to be very well planned how to do it.
Thank you for saying that. Saskia, I wonder if you would like to somehow react to what Maya said.
Yeah, we see the same problems in German cities because we are also using this cuboid method, which was published in 2008 and the first time developed for the city of Frankfurt am Main. And we also using this method to calculate these climate projection data for different cities in Germany. And we also compare this with our colleagues at ZAMK, and we see the same problem. And because of the densification in the cities, or in most of the German cities, especially in the south and in the west, there will be a huge problem in the future, and we need to adapt these cities to these heat waves and to the heat in the city.
Do you see some real change when it comes to decision makers? Are they really listening to you guys?
Yes, so we see there are a lot of cities in Germany where the decision makers have this problem at first or at the top fifth priority. So it's a huge topic within the cities and city authorities, and especially the huge cities like Berlin and Hamburg and Munich. They are doing a lot for climate adaptation, especially the greening. So the green and the blue infrastructure, as Maya said, is a huge topic. So we are talking about more green in the city, more trees, more parks, green roofs is a huge topic in German cities. So this is what it's changing right now, but the steps are too slow. So we have to do much more to adapt to the middle of the century.
I'm glad that you, as scientists, you are the whistleblowers and that you let the people in charge know about all the changes that are important and that are needed. Hopefully they listen even more. Events like this one are very important, and I'm glad that Wetterbericht is with us. Oh, sorry, Wetterdienst, right?
Yes.
Yes. I'm sorry, sometimes my German tricks me a little bit. So
it's perfect.
Yeah. So I just wanted to say that alles war sehr sympathisch und vielen Dank und vielleicht bis bald.
Thank you very much. Have a great time.
It'd be great, and a big round of applause from Warsaw. I hope you can hear that. Thank you. It was really great to be able to talk to you. I hope you have some great lunch plans in Germany and in Austria, because we actually have them here in Poland. So we're about to take a break, and I hope that everybody gets relaxed, but also re-energized and re-nourished, if that makes sense. So we will have our third session on the climate change just after the lunch break. We'll start with satellite data as a modern tool for environmental monitoring of the Baltic Sea. And then we will also have some machine learning approach, and that will have to do with dioxide pollution. So it's about time that we just enjoy everything that's here to enjoy. I'll see you in about an hour. Thank you very much. Hello, everybody, and welcome. This is the Earth Observation Forum. This is our second day, and we've just finished the lunch. Thank you for coming back. Thank you for tuning in, and thank you for your persistence to learn about Earth observation and just for your open-mindedness. We're definitely calling for even more open-mindedness for the very last part of this event. There will be some great news, but the most important topic on our agenda is the climate change. We're joined by Professor Mirosław Darecki from Polska Akademia Nauk, that's the Polish Academy of Sciences. It is great to have you, Professor. You work at the Institute of Oceanology? Oceanology. Can you say that again?
Oceanology.
Oceanology. Is that okay? Close?
Yeah. It's
okay.
Thanks, right, yeah.
So please welcome Mirosław Darecki.
Okay. Okay. Good afternoon. I was asked to say a few words about non-scientific application of the data, satellite data we are working with, and we provide in our services. But before I will present those examples, I would like to say a few words about data we're working with and problems we have to, excuse me, it's not that one? Okay, and problems we have to face to solve problems and to provide good quality products. So one of our interests is ocean color. We know from our life that ocean or marine waters has different colors. For us, the color of the ocean is the indicator of the quantity and quality of the dissolved and suspended substance in the seawater. So the content of the seawater we can measure based on measurements of the water leaving radiance, so there is light which emerges from the sea, what is called ocean color. And what is more important here, that this ocean color can be seen and measured, what is important, also from satellites. But we have to face here some quite significant problems. The first one is the cloudiness. In rare cases, like on the left, we have some nice cloud-free area from which we can get information. But typical cases are the cases like on the right side. We have only small area visible, and sometimes or quite often we do not have information at all. And on the other side, taking into account high spatial and temporal variability of the many properties of the Baltic Sea, this is example of the development of the phytoplankton bloom on the Baltic. Images presenting situation 3 days in a row. So each day we see that the situation is very, very different. So to make an assessment, to investigate this kind of properties, this kind of features, we need information on a regular basis. So we need to get this information every day. We couldn't wait for the next cloud-free day, yes? So there are some statistical methods which can help us in filling the gaps in the satellite images. I listed some of them, but after some years we find out that no statistical methods can provide us kind of information we need. So we came to the conclusion that only recently developed ecohydrodynamic models can be good solution to solve that problems. And this examples how we are able to fill in the gaps in the sea surface temperature image. We see on the top image, we have natural scene from NOAA 18 satellites. On the bottom panel, we've got information completed by modeled data. We see it's even difficult to find out where we have where we are dealing with real information and when we are dealing with modeling. But this is only when modeling is good and model are filled in with satellite data before. So to put that into practice, we built some quite sophisticated and complicated system, which is called SatBaltic system. I had the opportunity to present this system some time ago, so I will be not going into too much details. But what is most important, we have actually two subsystems. One is the satellite processing system, and one is the modeling system. We're running few models which exchange information with satellites information, and in cases where we have cloudy days, we get this information from the models, but in case when we have nice cloud-free areas and we are able to provide satellite information, we can even feed the models, and models, thank you to this, improve the quality. Of course, both subsystems are also calibrated and validated by in situ data on continuous manner. So the merging of satellite and modeling data are not just straightforward, because depending on the parameters, sometimes we are using mosaicing of satellite images. So we're taking some images from day before, 2 days before, 3 days before. That depends on the variability of temporal variability of each parameters. So we just make some mosaicing in time, and this mosaics in the final step is merged with modeling data, and we've got products. So as a result, we have some operational system which providing the maps for the whole Baltic or for many parameters which are mostly related to the climate change, to the eutrophication of the Baltic Sea. This is examples of the chlorofillic A concentration, which is related to the phytoplankton content in the Baltic and to the primary production on the right, so how much organic carbon is produced daily in the water column. I would like to point out on the data, because the system started in 2015, but we have time to process also some historical data, and at the moment we have 20 years of images about different parameters in the Baltic Sea. So actually we can quite effective investigate recent changes in the Baltic Sea. And now I would like to present some example how the system can be used and was used in practical applications, so not related to the science. So the first one was the assessment of the state of the Baltic Sea for the period 2011-2016. Our country, like each country around the Baltic Sea, is obliged to provide every 6 years report about condition of the Baltic, of some regions related to our coastal, and how it is usually done. We have some sampling station. Few times per year we going there, taking water samples and trying to describe the water properties from these water samples. What we can offer, and it's easy to guess that it's quite limited number of measurements, yes? We have few points, we are able to go there in the year at least 3-4 times per year maximum. And based on that, we trying to calculate, to characterize the whole area. Our solution is to provide everyday information and also information for each pixel in the region. So the traditional statistic is based only on several measurements. In our approach, we have, for each area, we have several hundreds of the points taken into account in the statistics. And there is some results we've got from our analysis. This is averages of the sea surface temperature for the summer in years 2011-2016. Summer is the most productive period in the Baltic Sea, so that's what's going on during that period is quite important. You will see that there is no significant increase in the sea surface temperature. We have some decrease even in 2015. That was due to some special, unusual meteorological condition over the Baltic Sea, but we have the slightly increase for the whole area as well. This is example of the chlorophyll concentration. As I already mentioned, chlorophyll is the indicator of the phytoplankton. This is the main organism in the Baltic Sea, main producer of the new organic matter. And also there is some variability during the whole year. When we focus on the summer months, we see quite strong variability year by year, but only, or maybe not at all, increase for this period. And of course, these results couldn't be accepted without comparison with traditional monitoring. So we made also this exercise, and we see that on most cases we are pretty well matched the traditional measurements. What actually we were surprised, and that was actually luck for us. But traditional methods provide from sometimes quite unusual peaks. That's because, you know, these few measurements actually have been taken in the, let's say, very, very high bloom area. But in just normal cases, these methods are comparable. What is good for actually satellite, because otherwise probably our result wouldn't be accepted. But definitely our approach is much cheaper, and I think we do believe, we are pretty sure that it is much more statistically confirmed. So based on that, I think the administrative couldn't still accept that this, probably this is also because regulation, that the satellite monitoring can be only tool, but actually they came to the ideas that we can help in planning of the traditional in situ monitoring by assessment of the representativeness of the selected monitoring station in this traditional monitoring for selected areas. And we just make some exercise also in this direction. That was the work we've made for Chief Inspectorate of the Environmental Protection. So we just analyze, you know, this is example of this area. So we have few sampling station, and based on this sampling station, the average values are calculated for each year. And they ask us if they do have all these measurements on all this station, maybe some station doesn't provide any additional information, doesn't improve the means in any way. And we made some statistics. This is example. So we analyze each station which usually has been taken account in measurements. And for each station, we analyze this determination, the distribution of the coefficients of determination, how this station is related to other values in the sampling area. And based on that, we are able to provide some output. This is example of how we assess this outer Pusk Bay basin. So there are 4 stations in traditional monitoring, and based on our analysis, we made recommendation that you can easily remove 2 stations, what actually make quite a big savings for agency, because they don't have to put samples on 4 points. 2 points is enough to get the same results. We made some also from some other parameters. This is maybe less related to satellite data, but in our final report was this kind of conclusion. And thanks on that data, I do believe that agency makes some significant saving. Another example of the application which we working with in the last years is related to new possibilities in marine science, which are thanks to satellite data with higher spatial resolution. I mean Sentinel-2 data, because before we did have Landsat, we have some commercial satellites, but they are not so operational. As you already know, we need information only on regular basis on quite often. Landsat could provide our information every 14 or 16 days, if I am right. With Sentinel-A and B, we have information about 2 and 4 days. That's the kind of information we can work with. And we compare traditional resolution of the ocean color images. This is example of the MODIS Aqua image with Sentinel-2 image with 10-meter resolution. We see that we have something really, really new. Yes, this is an example of the visible pollen plumes at the Gdańsk Bay. At the traditional, this ocean color images on the left, it will be difficult to guess what we're dealing with. On the right side, we have nice pictures, and we can investigate not only this those plumes of the pollen, but also dynamic of the surface waters. And of course, how to utilize that. This is something new, and we're working on that problem from a few years. And one of the solution application in which we have been using this data was monitoring of the aquacultures. We were taking part in 2 projects, Optimus from the Bonus and Impact Horizon 2020. And the project, those 2 projects were about aquaculture, how to monitoring aquaculture, how to improve the quality of the production in the aquaculture. And we providing there the information from the satellite data, from Sentinel-2. On the example, we see the aquaculture of the mussels. So we have the lines, underneath the lines are ropes, and to the ropes are the mussels connected. And when we analyze the area when the farm exists, we see on the left images, I'm sorry, it doesn't work. You see that this is border of the farm, but it is put artificially. And if the farm is inactive, so there's no production on the farm, we see there is nothing new in this area. So you have natural variability in the water transparency. This is chlorophyll concentration. But when the farm starts to be active, so the mussel starts to growing, we see that the water starts to be much more clearer and the chlorophyll content going down. That's because the mussel using all nutrients and we do not have development of the chlorophyll A concentration, yes? We do not have development of the phytoplankton. And this is confusing, and we put some transect line, we see it's more clear. On the right side, where the farm is active, we see much, we should definitely decrease in the here is chlorophyll concentration. So, analyzing some time series of the data, we are able to track the condition of the farm. We are able to track what something wrong is going on. So when the production of the mussel stops, so maybe there was not enough nutrients. And that was actually quite effective tool for the management of the aquaculture. In the second system, actually in the second project, we developed some what we call intelligent management of the aquaculture, and from project was already finalized, but as I already know, the system is already used on practice. So another application, but I not have time to discuss it about in more details, is to using satellite data in the maritime and territorial spatial planning for the Baltic Sea. That's another project we are running at the moment for the ESA Baltic Regional Initiative. And among many parameters, we be able to, in this project, to provide bathymetry and benthic habitats for some selected test sites. Among them is Gdańsk Bay. But about some results, I hope I'll be able to discuss on the next meeting. That's, yes, in some summary. So merging satellite data with numerical models can utilize advantages of the both satellite and numerical data simulation, and at the same time reducing their errors. And this method, of course, can be used in the assessment of the ecosystem health of the Baltic Sea, providing more statistically confirmed results. Data also can be used for validation, traditional monitoring, and modern satellite data can increase spatial resolution, opens up new possibilities in remote sensing of coastal internal waters. Okay.
Thank you, Professor.
Yeah.
Thank you very much. But please stay for a few more minutes, because I wonder if our audience has some questions. Yes, we do, and I'm so glad.
Thank you for a nice presentation. My question might seem kind of minor because it regards the cloud coverage.
Could you speak lower?
Yeah. Can you please elaborate a little bit more on the model which you use to fill up the missing parts, basically the clouded areas? Because you mentioned that you stick together, you mosaic a couple of neighboring satellite images, but you fill up the rest somehow with
model. Yeah, that's very complex. Modeling is another part of oceanography. Yes, so we are actually running at our institute 2 different models. One is POM, one is what we call EcoSat models. This is developed with cooperation with University of Gdańsk. So this is traditional, oceanographic hydrological model, but we added to the model some biology, so some content related to the phytoplankton, some content related to the marine life. Yes, not only physics. And I can just maybe propose you some publication, and many of them where the model are described in more details. But this is just typical hydrodynamical models, and adopted to the simulation of satellite data on the one side, and also adopted to some parameters which we would like and we are ready to provide from satellite data. Probably not answered for your question, but it's probably
it kind of answers
to describe the models. We need a few hours
to provide the title of the publication you mentioned.
Right.
Yeah. I can just.
Thank you.
And you can go to Sat Baltic system, Google it, and you have all information. Yes.
Sat Baltic.
Sat Baltic.
Sat Baltic. Okay.
Sat Baltic.
Thank you.
You are welcome.
Thank you, that's great. And Professor, maybe you could write the name of the publication in the comments section of our YouTube transmission.
Only I have access to that?
I'll give you access to that on my tablet, because I think our viewers online will also appreciate that. So thank you very much, Professor. I will just approach you with the tablet after this. And this being Marcin Kawka of the Institute of Environmental Protection, National Research Institute, probably the institution that has been represented here most often. You have been to this conference, many of your representatives have. So this is again about climate change, isn't it?
Well, I would rather say it's about air quality.
Air quality.
Yes, it's somehow related to climate change, but it's a separated aspect.
Right. So this will also have to do with Earth observation, and this data can help?
Yes, it's atmosphere observation, so atmosphere is a part of Earth ecosystem, let's say. So, yeah, it's related to Earth observation.
Right. Marcin Kawka, everybody.
Thank you. Okay, so I would like to tell you something about the application of remote sensing of nitrogen oxide emissions. So I come from Institute of Environment Protection. It's a It's a national research institute which was founded to advise the Ministry of Environment with an independent expertise. So in general, if the Ministry of Climate and Environment wants to know something about a specific scientific aspect, it should not ask private consulting company. It has its own institute to get an independent answer, a non-biased answer. So we do some research, and about 50% of our job is advising the ministry just with our expertise. So I would like to say a few words about national emission inventory. Emissions are an emerging subject, especially this winter. Then I will tell you something about air quality forecasting at the Institute, which is based on the emission inventory. And then I will switch to Earth observation with Sentinel-5P and the Tropomi instrument. And then we will compare the air quality from the forecast and the air quality observed with Tropomi instrument. And we would like to see what are the conclusions for emission inventory. So what is emission inventory? Basically, it's a database which collects the information how much of a particular pollutant was emitted by each emitter. So here you can see a small village in the south of Poland, and each house has an associated point. It's a spatial database, and you can see how much of nitrogen oxide, how much of PM10, or how much of sulfur oxide was emitted by each emitter annually. So it's a scalar database. We don't collect temporal profiles. Obviously, this is an estimation, so just keep in mind that a standard semi-detached house emits between 1 and 10 kilograms of nitrogen oxide per year. We will focus on that number a bit later. This emission inventory is based on BDOT, which is a database of all topographic objects in Poland. It's a vector database, so we have every house in Poland basically in this database. Depending on the region, some regions have very good databases of their own citizens with detailed information about what kind of fuel they use, how much gas, how much coal, etc. And some others, they don't have it, so we use kind of an estimations that for this climate we need to heat this type of building with that much of coal, and this is then transformed to the amount of pollutants that are emitted. This database is basically updated annually, so in January, February we have data for the previous year, just when all the data get collected. It supports SNAP sectors, which means that buildings are separated into 10 classes, including residential buildings, industry, schools, administration buildings, agriculture, transport, and so on. And the temporal profile is not included. So we also collect industrial emissions, and Poland is lucky to have the highest NOx point emissions in Europe. So we have this Bełchatów power plant, and they have 2 stacks, and each of them emits about 8 or 9 million kilograms of NOx per year, which means basically that they emit the same amount as 20 million detached houses. So it's a huge amount, but these stacks are quite high. They are more than 300 meters high, so these pollutants get diluted in the atmosphere. In the past, they used to emit like 7 times more. So there were some complaints from Sweden that these pollutants, they used to travel on a very long range, and they used to cause some even acidification of Swedish lakes. So that's how serious the pollution there is. So the amount is very high in compared to domestic NOx emissions. And so how to distribute these scalar numbers during the year? We use so-called emission profiles, and there is a database which is called EMAP, based on EMAP convention, and they somehow have standardized how energy is used during the year. So here you have 2 examples, SNAP 1, which is basically the residential sector, and SNAP 3, which is the industrial sector. So for SNAP 1, you can see very low emissions in the summer because we don't heat our houses in the summer. and high emissions in winter. This is standardized, so if you integrate this curve, you will get 1 for the whole year. And the industrial emissions, they are more or less the same during the year, so the power plants are operating basically constantly during the year. The emissions are not bigger. And these emissions are our input to air quality model. At the Institute, we use GEMAQ. It's an air quality model developed by Environment Canada. We used to have some scientific collaboration with the University of York and Environment Canada, so this is why we use GEMAQ at our institute. Also, WRF-Chem is a quite popular replacement, also used in Poland. Every day we produce a forecast for 3 days for air quality of the major pollutants, including PM10, NO2, SO2, and tropospheric ozone in the summer. And this is done with vertical resolution of 28 layers up to high stratospheres or up to 10 hectopascals with a 2.5 resolution horizontally. So basically it's a regional model, and we deliver the results directly to the Chief Inspectorate of Environment Protection. If any of you received an air quality warning for your mobile phone, this is basically, the source of this information comes from our forecast and from GEMAQ model. So here you have an example animation with NO2 over Poland. 3 days, 9 to 10 October 2022. So these were the very warm days in October, which happened recently. You might have remembered them. So sometimes you can see basically the urban structure in Poland, including the main highway from Warsaw to Berlin. But then there is some wind coming from the west, and everything is washed out basically from Poland. So this is to show you how dependent the air quality is from meteorology and from the wind speed. So if it's windy, then the air is sufficiently good. But if the wind stops, then we have serious air quality issues over Poland. So this is how we transform the emissions expressed in kilograms per year into concentrations in micrograms per cubic meter. So what does it have in common with Earth observation? There is an instrument called TROPOMI on board Sentinel-5P satellite. It's an optical instrument, but it works outside the visible range. So normally with satellite systems like Landsat or Sentinel-2, you have optical sensors which work in the visible range, so they are used to observe the Earth surface or ocean surface, but generally they don't look at the atmosphere, they look what is below. And TROPOMI on board Sentinel-5P, it's kind of opposite. So it has some bands in ultraviolet and some bands in infrared, and everything is combined into watching the composition of the atmosphere. So we get basically the things that are called noise and atmospheric influence for most of the optical satellites, just to estimate the concentration of trace gases like NO2 or ozone. The resolution is quite nice, 3.5 per 5.5 kilometers. And we have 1 day revisit time, so basically every day we have an observation of NO2 above Poland and above the whole Europe. The units are quite interesting and a bit unusual for someone who works with chemistry. So these are moles or molecules per area unit, usually per square meter. It's very sensitive to cloud cover, so we have all the same problems as my predecessor said already with the BALTSAT. We have those problems too with TROPOMI. But obviously you can build a mosaic for a monthly average. It's called a monthly average, but it depends on the cloud cover highly. What do we see? Do we see the surface concentration? That's another aspect. So there is something which is called averaging kernel. If a satellite looks from the top at the atmosphere, it collects the signal from the atmosphere starting from the top. And if there is a lot of NO2 on the way to Earth's surface, the sensor gets saturated, and the answer, the value of the total column does not come from the total column, but it comes from the top of the column. So averaging kernel basically is the distribution of the satellite signal from which altitude we get the answer. And it depends on the location, and it depends also on other trace gases, and it depends on the cloud cover. But generally, there is a very low signal from the bottom of atmosphere, from the Earth's surface, which is not good for us because we are usually interested in the surface concentrations because these are the concentrations that influence our life. So here you see the total column number density. This is basically the amount of nitrogen in the atmospheric column taken from the GEMIQ model. So most of the tropospheric nitrogen is below 1,000 meters altitude. And the averaging kernel, so the satellite basically sees usually the higher troposphere. It does not look so, it's not very sensitive to the surface concentration. But also it depends on the situation in the atmosphere. So in the summer, when it's windy, the atmosphere is highly mixed. But in January or February, where we have no wind, where we have atmospheric inversion, the pollutants between lower troposphere and higher troposphere, they don't get mixed very well. Okay, so let's come back to the cloud cover. So here you can see an example from January 2019. With each TROPOMI dataset, there is a quality value associated with each pixel, and the atmospheric theoretical background from KNMI, Dutch Institute of Space, tells us that 0.75 is a minimum threshold of quality value for the TROPOMI data to be useful. So if we assume this 0.75 threshold for the quality value, the number of acquisitions in January over Poland is between 0 and 10 per month. So it's very cloudy in January in Poland. Also the same is in February, December. In general, autumn, winter, and early spring is usually cloudy. If we lower the threshold to 0.7, so not to be that strict on data quality, then we have a bit more of acquisitions, but it's very risky to interpret them in a quantitative way because we can bring some artifacts into our algorithms. So this may be a concentration of nitrogen dioxide, which is in fact a water vapor. So it's not very good to lower the threshold, but I just show you this to give you the information how the number of acquisitions may increase. Okay, so if we look at the results, assuming the 0.75 thresholds in January, it's not very useful. So on the left, you can see GEMIQ model, and on the right, you can see TROPOMI satellite sensor. This is a column sum with averaging kernel, and on the left, I also extracted the results from the model using the same averaging kernel from the satellite. So this is basically what a satellite would see if it would be fed with the modeling results. That's from January. But if we switch to April 2009, April is quite good for Earth observation because it's not that cloudy as in winter. So we can see the major points with high emissions. These are the modeling results, and these are the TROPOMI results. So there is basically a bit more of nitrogen oxide if we use satellite than compared to GEMIQ model. And the same in June. Here we get much closer. So still we have the point emissions from the big power plants. And the same is in TROPOMI. There is a question what happens in Gdańsk, because we see a lot of nitrogen dioxide with TROPOMI, which is not visible in the modeling results. So we can also extract results at major NO2 stacks at bigger power plants. And we see that the order of magnitude which is observed with TROPOMI and the one which is extracted from our air quality forecast is quite similar. But if we integrate it in a different way, so just to show you the difference temporary, the difference has some patterns. So basically we have an underestimation in the summer and an overestimation in winter. So we need to do something with the temporal profile because the amount is more or less the same per point, but if we distribute it in time, we have underestimations in winter and overestimations in the summer. So just a conclusion, Tropomi seems to be a useful way for validating air quality models. Sentinel-5P stands for precursor, so it's a first satellite of the new family of satellites for observing air quality in the atmosphere. So they will probably be also useful tools for validating air quality models. The thing we need to improve is the temporal profile, which we have from the EMAP convention. We need to try some different temporal profiles just to check if they may play better. So just some references. You can access our air quality forecast at the page of Chief Inspectorate of Environment Protection. We also deliver a forecast for CAMS regional model with 10 kilometers. That's using the same model with different emissions. And we also publish an APA interface for our forecast. You can use our data in your own applications. And we have published 2 papers describing the emission inventory and validation using Tropomi. So thank you.
Thank you very much. So do we have some questions from our great audience members? We do, and from our frequent contributor here.
Thank you. My question is, if the satellite Tropomi data is good for validation, why not to use it for data assimilation into the model?
Thank you. I was waiting for this question. No one has done it so far in a convincible way. The reason for this is that nitrogen dioxide is an active compound. It reacts with ozone. There is a photochemical reaction. It destroys an ozone compound, but it's also a precursor for ozone compound. And if you assimilate the Tropomi data, then you put some new mass into the system, and basically you destroy the balance between nitrogen dioxide and ozone. So you need to do it in a smart way, and there is no consensus how to do it yet.
Looking at his face, our attendee seems convinced by this explanation. Thank you very much, Marcin Kafka. It was great talking to you.
Thank you.
All right, and now the topic is machine learning approach to estimate ground level nitrogen dioxide pollution. So the difference between these two presentations, thank you for passing the torch. It'd be nice if you guys do that. It's very symbolic. I love it. So the difference will be, first, Patrick's presentation will be more statistical, but it also will be pretty practical in that it will have a demonstration of something that can be done using some of the data from the satellite. So it's great to have you, Patryk Grzybowski. Great to have you. And as soon as you come on the stage, we will just give you a big round of applause, okay? Or you want to stay here?
I want to stay here.
You want to stay here?
Yeah.
Okay, you still get your round of applause.
So hi everyone. Today I'm going to tell you about how to use, again, machine learning approach to estimate ground level nitrogen dioxide pollution. It's part of my PhD thesis. So why is it such kind of study? So firstly, as we know, the air quality over Poland is very poor. So if you want to fight with something, to mitigate some effects, we have to know, to know something about our enemy. So we have to know when and where this air pollution is occur, yeah. And now we have data from Chief Inspectorate of Environmental Protection about nitrogen dioxide concentration, but it's pointly data, yeah. It's measured about 150 points over Poland. And satellite data, which I'm going to use within this research, and some meteorological data, is aerial data, spatial data, so it's so it could be used for some bigger areas. What is more, this Sentinel-5 mission. Sentinel-5P mission is kind of new. It was started in 2080. Data is providing from July 2080. There was no such many studies about that. Like, for example, for OMI, which was the predecessor of TROP-OMI instrument. So many things about Sentinel-5P was said before. Just quick reminder, temporal resolution 1 day, spatial resolution 3.5 per 5.5 since August 2020. What to say more? There are more products, not only nitrogen dioxide, there are also sulfur dioxide, carbon monoxide, methane, aerosols, formaldehydes, ozone and clouds. But what I'm using is nitrogen dioxide column density. And again, some kind of reminder that satellite data is not the same on what the ground measurement is. The satellite data is some kind of amount of content of pollution from the sensor to the ground level, and ground measurement is some point specific for some point over the ground concentration of nitrogen dioxide. So it's not the same. There are different physical values. What is more, as I said, I aimed to compare these measurements, satellite measurements, and ground measurements with each other. And the problem is that this spatial resolution is really good, this 3.5 per 5.5, but still, in comparison with 1 point, it's huge area, So some points, some measurement stations are not representative to the area of pixel, and this is the problem, is that area of pixel is not representative for such kind of comparison sometimes. So I have to exclude some measurement station. And the Warsaw is a great example because there are 3 kind of stations on Kondratowicza in the north of Warsaw, which is located at the edge of the pixel, but this pixel is in fact some homogeneous area, Station at Aleja Niepodległości is located, in fact, on the street, and this 1 pixel, it's not whole 1 street, And Wokalna is also this pixel is heterogeneous spatial land cover. And what I want to do was to create some regression model, machine learning model based on Sentinel-5P data, meteorological data, socioeconomic data, which I called here anthropogenic data, and elevation. I assimilated it and predicted surface NO2 concentration. A lot of data was used within this study. Four methods were performed to benchmark. So firstly, linear regression with 1 variable. It was this TROP-OMI NO2 tropospheric vertical column density, multilinear regression with several variables, not only this satellite data, but also air temperature, pressure, solar radiation, etc. The same variables for random forest and for support vector machine. What is more, I added to this method circulation type, which is categorical factor, and that's why I use this machine learning methods also to include some categorical data. And what about results? This is results for hourly measurements, hourly, but in fact the measurement at the moment, for the hour of the satellite acquisition. In the A chart, there are results of linear regression, B multilinear regression, C is for random forest, and D is for support vector machine. that the validation shows that mean percentage error was about 50% for linear regression, so it was not good, yeah. But when I use more data, more variables, I found that multilinear regression gave accuracy better, about 6%, and machine learning methods provide accuracy better, about 5%. And similar situation with prediction for weekly averages. Results are a little bit better. Again, the accuracy is better for more complicated methods. And as I said, yeah, these machine learning methods provide better accuracy. So it was totally reasonable to use this more time-consuming, more power-consuming methods because the accuracy in comparison with some, maybe I should say, the traditional way of regression, it's better about 10-20%. For this random forest approach, I verified the variable's importance. So I found that so the most important variable was Sentinel-5P data. What wasn't surprised. What is more, there were two groups of variables which were important: night light, planetary boundary layer height, density of rows within the pixel, solar radiation, and population within the pixel. Excluding these variables from the model influenced on increase of mean squared error more than 10%. And the second group of variables, which was temperature, wind speed, elevation, pressure, and circulation type, excluding, maybe not excluding, but permutation of these variables gave accuracy decreased about more than 10%. I compared with my results with CAMS ensemble median. What I found it was that this random forest approach is more sensitive on the areas around the cities. It's not visible, I think. The font is too small. But this is Szczecin, this is Gorzów Wielkopolski, and we can see that on the random forest approach, the air pollution in Szczecin is kind of different than around the Szczecin, and the same situation is in the area of Gorzów Wielkopolski. When I used CAMS ensemble median, the air pollution in Szczecin and next to Szczecin was practically the same. So in this case, this random forest approach was more sensitive. But on the other hand, for example, CAMS model is better for some detecting pollution for road transportation. We can see that here, yeah. This is A1, yeah, from Warsaw to Łódź and then to Katowice. But this random forest approach is better, has a better accuracy. But in comparison in CAMS, it's completely dependable on clouds. Yeah. So if there are cloudly images, this data couldn't be used. And what I want to show you at the end of my presentation is application. Could you switch on my laptop? Oh, thank you. Firstly, what I'm going to show you is not about this model, which I described before. It's about nitrogen dioxide only from Sentinel-5P. This application is based on Google Earth Engine platform. It's really easy. Some kind of beta version now. You can choose the start date. So let's calculate the mean average NO2 pollution for 2090. So year, month, day, end date, load. It should be calculated quite fast. So we have to wait. What you're gonna see for the moment is average nitrogen dioxide pollution for 2090. But of course, it will be disrupted, yeah, because a lot of data is collected during summer, during spring. There is poor amount of data for winter, for autumn. Oh, you can see it, and it's quite similar what was presented before, yeah. And if you want to calculate the average for any period, you can type here maybe one more example for 2020. Why 2020? Because in April 2020 there was a big, huge fire in the Biebrza National Park, and I'm going to show you how it was seen by Sentinel-5P. You can see that there is a lot of pollution around Białystok in the area of Biebrza National Park. In the area which is usually clean area, but on the other hand is kind of misleading because this signal, this retrieval also becomes from some particle matter which are connected to fire. So it could be misleading. There was air pollution, but maybe it was not connected strictly to the NO2. Thank you.
One question. Can we have the screen again? Because I have one question for this screen situation. It will be back. So would you be able to check for like March 2020 when COVID started and the businesses wouldn't work and I guess people wouldn't travel too much? Do you think that it can be?
I verified it because I wrote an article about that.
Right.
And in fact, in March, the pollution was slower.
Okay.
But the biggest differences were observed in April when we're not allowed to go to forest, for example. Yeah.
So this map that you showed, you also showed it for April. So it'd be pretty much the same.
Yeah.
Okay. It's okay. Yeah. But it was also the month in which there was the fire, you say?
Yeah, but only for this area, yeah.
Okay, okay. Thank you for showing that. It's actually here. And I wonder if our audience members have questions to you, because they might be interested in this data. And this region?
Katowice, yeah, it's the most industrial region, so.
And it was also during COVID?
Yeah.
Yeah, because people probably still needed to warm their houses, for example.
Yeah, and I forgot to say about that there is also an option to get a time series chart when you click on the map, for example, for Warsaw, yeah, there is generating charts. It's not interpolated. There are only measurements which were obtained during observation.
Yeah,
it's working here, so I think that for the moment we will be working on the screen.
What can I say? It all seems pretty legit.
Thank you.
Yeah, I've got a lot of trust in you. Thank you very much from our audience. Thank you. And while you're working on your laptop, I'd like us to hear from Ms. Jolanta Orlińska from the Polish Space Agency, because she will join us here to pretty much finish this conference. Can I please ask you to come towards us? So, Ms. Director, a great company for the last 2 days.
Yes. So thank you very much for the English-speaking people that you enjoy our event. We are very grateful. We are very happy that you are with us. And today we invite you next year for the Earth Observation Forum, new challenges, new information, new data, new people. Please join us.
So we're not done here. It's not the end. Next year we're going to see each other.
Of course, this is
okay.
Conference, which is good.
I love the declaration. Please give it a big round of applause. So that is perfect. And to have the perfect conclusion, let me also introduce Annalisa, because they have co-produced this event with us, and it was a great honor to be here with you, with Eurisy. Thank you.
Thank you very much, Matt, and I can only echo what Yolanda just said. I mean, this is just the beginning, and we want to bring this solution closer to the users, and this is our way to actually raise awareness on the potential of satellite-based application on Earth observation specifically today. And yeah, I mean, the topic of that we heard about today, from agriculture to forestry management, to water management, to climate change services, to renewable energies, I mean, are at the very heart of the decision makers. So we believe that this needs to grow, and yeah, I mean, we hope that everybody enjoyed this conversation. We will keep on doing this, and I thank very much the Polish Space Agency for the great cooperation in doing this, and the E-Shape project, all the different partners that came here to present their work, and see you soon.
And the attendance at the end is pretty impressive too.
Absolutely, absolutely. It was great to see actually the interest of the people and the engagement, so that's great.
It is. Annalisa Donati, thank you very much.
Thank you very much, everybody.
And let me please take this opportunity to thank all the people, especially on the Polsa team, because there is this big number of people who've been here. Most of them were this little lapel pin that I asked them for, actually. And today they let it go, and they said, okay, you'll have your own. So it has taken me like 24 hours. It was like building momentum. And I appreciate that Oscar actually gave it to me. But it isn't just a lapel pin, it's something more. I think it's the integration. I think it's all the talks. It's the hours that we've spent working together. It's all the countries represented here, like Italy or France or Denmark, and all of the neighboring countries, Germany today, Austria. It was really, really impressive. I also wanted to thank the event planning agency, Platishimash, and all of their subcontractors, the great technical team, our interpretation friends, Pavel and Sonia, but also the people who help interpreters work, because it's not that easy to establish this booth and make sure it works. By the way, we would love to make sure that you give the earpieces back, because it happens pretty much every event that a few are left, and we always have this amount of money in our budget, just so that we know if somebody takes it home, we'll say, yeah, it's okay somehow. But it'd be better if you don't. So we would really appreciate you you giving it back. By the way, thank you for giving back so much to us as the organizers. I really love the interactions, and I'm so glad for all the words that we exchanged. So stay great, and let us explore this Earth even further, and hopefully see you next year. Thank you very much. I'm Maciej Kautz. Thank you. Yeah, and have a great day ahead.